Okay, good morning, everyone. It's a real pleasure to have you all here. A very warm welcome to this online event, online exchange on the food systems, food research, innovation and partnership for the Green Deal. I have been very excited about this event for the last few weeks, and it's nice finally seeing and bringing it together. The aim of this morning is to start a dialogue, to start an exchange between science and policy. We're going to use the microbiome as an example. And what we are hoping to come of this, at least from MicrobiomeSupport side, is that in the long term, we find opportunities to exchange with each other, maybe a little bit more regularly, a little bit more earlier, so that in the long term, we can make sure that the microbiome applications that science can deliver for a better environment, for a better food system, for better human health, that these innovations are going to be impactful and that they're going to deliver on the promise and the potential that they have. So my name is Bettina Schäkle. I am a senior manager at the European Food Information Council, or short EUFIC, and I will be guiding you through this morning. The event is structured in 2 sessions, and we will have at the end of each session a panel discussion where we will have an exchange between those of you who are involved in the scientific part of microbiome applications, those of you who are more involved in the policy making of microbiome applications. But the very first thing I would like to do is welcome our host, Ms. Elsie Katainen. She is the Vice Chair of the Agri Committee in the European Parliament and member of the Renew Europe group. She is an agroechologist and a teacher of vocational subjects by education. And as an MEP, she was also the chairperson of the Women's Organization of the Centre Party for 6 years. Elsie very kindly is hosting this event for us. So I'd like to give her the floor to join me with a few welcome words to the group as a whole. Elsie, the floor is yours.
Thank you, Bettina. Thank you very much. Dear participants, I would like to warmly welcome you all to today's webinar on microbiome pathways to food safety and farm to fork. How do food research, innovations and partnership help us to deliver the targets of Green Deal? Like you heard, I'm Elsi Katainen, Finnish member of the European Parliament and the Vice Chair of the Committee of Agriculture and a member of a Transport Committee. Agriculture in general is a very familiar sector for me professionally as well as in practice, since I'm a teacher of agriculture and natural resources. And I have worked as a dairy farmer with my family. 2 years ago, we made a generational renewal at our farm, which is nowadays run by our son. The Russians' terrible invasion to Ukraine and ongoing war has changed the Europe. It has also shown that our food system's security cannot be taken for granted, as we see that global food system has changed. The security of supply in Europe is seriously threatened by the rise of energy and food prices and the lack of raw materials. As Europe needs to give full support for Ukraine, at the same time, more than ever in European policymaking, we need to pay attention for securing our food supply. It is unfortunate that only a war is an alarm signal which wakes Europe up. As new packages are now being built to meet the changing situation in Europe, the profitability and the conditions of food production must be at the core of it, otherwise we run out of food. Investing in science is part of this solution. That is why the theme of our event today is more than topical. Microbiomes are essential in our everyday living. We must harness all the potential of this sector fully. The microbiome is a vast community of bacteria, viruses, and fungi in humans, animals, soil, water, and environments. EU research in this field has opened our views to this universe because these tiny little things are everywhere, and they may run the world, as we have seen during the COVID crisis. This leads to a strong need for research and innovations for reaching our goals toward a more sustainable agriculture production, as it is laid down in the Farm to Fork strategy. We need new innovations. We cannot afford scarcify food supply system to stay productive and sustainable at the same time. The Green Deal and Farm to Fork need to be achieved with novel and innovative approaches. There is also the need to deliver these to the farm level, that our farmers are able to benefit on the new innovations. Thank you to the representatives of the EU Commissions, the scientists, and my colleague MEPs who will contribute to our online conference and the panel discussion today. I'd like to wish you all an interesting webinar and looking forward for the discussion. Thank you.
Thank you very much, Elsie. Well, everyone, this is our what's it called again? You know, the gun when everything is going off and all of a sudden, basically it's our sign to go. So our first keynote speaker for this morning is Hans-Jörg Lutz-Eier. He's a scientific officer at the European Commission's DG Research Directorate on Biotechnologies, Agriculture and Food, and is responsible for research linked to agricultural policy, the European Innovation Partnership, and the European Research Coordination in the context of the Standing Committee on Agricultural Research. He holds a PhD in agricultural sciences, and this morning will be talking to us about sustainable food systems for people, planet, and climate. Hans-Jörg, over to you. You're still muted.
Thank you very much. And as Elsie Katainen pointed out, it's a sad time. On one hand, we are experiencing a war on European territory. And like with energy, we have to make sure our food systems are prepared, are resilient. And Antonio Guterres, the UN General Secretary, called yesterday for a task force which is looking into energy systems, food systems, and finance systems. And this shows food and energy are close, let's say, to people's livelihoods, and sustainability and resilience of food systems is at the core. Now I can't move my slide, unfortunately.
If you click on the slides, does that move things forward?
Ah, yes.
Yeah.
Yeah, why we need a European partnership on sustainable food systems. We have to make our food system, let's say, fit for purpose. We have to reduce inefficiencies in the food system. so that all efforts, all elements in the food system which draw on resources are really delivering nutrition to the citizen, to the consumer. So our food system has to be better linked to nutrition, and so we have to avoid overconsumption, overweight, so a better nutrition orientation of food systems. We have to respect planetary boundaries. We have to assure that the nitrogen, the fertilizers we are using are really efficiently used for plant growth, and that they are not ending up in the groundwater. And here, for example, the microbiome comes in. We have to assure that our system is not producing food waste, that with ICT tools, there is a better assessment actually of food chains, of food flows, so that what the consumer wants to buy in a certain week in the supermarket is on the shelf and not more than that. So that using all technology, new technology, to make sure that there are no inefficiency in the food system leading to food waste. Also, making consumers aware of, let's say, buying what they need and not over consuming consuming food. So there's a need actually for discussion with citizens, with consumers. And here the Sustainable Food System Partnership is coming in. As European Commission, we have the Horizon Europe Research and Innovation Program, which is a perfect tool for us to launch calls for proposals. We mobilize the research community across Europe and beyond, but 90% of all research and innovation investment is actually based on member states and regions. Therefore, it is essential actually to leverage what research and innovation investment is around in Europe and work together to also to avoid duplication. And the concept of the Horizon Europe partnership is actually about aligning, coordinating, leveraging European and national efforts, and also to provide the scientific evidence to improve our food system. Therefore, we propose the co-funded Sustainable Food Systems Partnership. And today is actually a crucial day for the food system partnership, because the Commission will send out a letter today to member states to ask their commitment for co-funding. And we expect replies by 30th of April. We are ready to put a substantial amount on the table, but we need co-funding from the Commission, from the member states, and therefore, today is a perfect day also to raise awareness on the food system partnership opportunities. We need to enable research and innovation to drive the food systems transformation process, using science and technology, being more efficient. And the food systems partnership is designed around 4 thematic areas and 4 activities. So change the way we eat, change the way we govern food systems, change the way we process and supply food, and change the way we connect food with citizens. So change the way we eat means improve the availability, accessibility, and adoption of nutritious, safe, affordable, attractive, and sustainable diets, so that healthy diets are actually the easiest choice, so that consumers easily actually find what is good for their health, and also depending, let's say, on nutritional behavior of different age groups, of different societal groups, and this has to be done in participation with the consumers. There are innovation centers across Europe who have actually food labs, and they could be brought to the front for making the food system more linked to healthy nutrition. So such could be an element of in-kind contribution, for example, for the partnership. Then change the way we process and supply food. Circularity is a keyword, so we need to close nutrient cycles. And this is even more important as we talk about a fertilizer crisis. So we have to use the fertilizer we have more efficiently. So we need new recycling and processing on demand methods. Also, I mean, your food should stay safe in the shelf. So we need conservation methods, which are, for example, also microbiome based, using the microbiome for clean label conservation methods more prominently. Diversification, we need to provide diverse diets and handle also biodiverse resources. This links also to strong local food systems. If we, for example, look at potential food crisis in Africa, it's due to imported wheat, and not all of these societies initially have been wheat-based. So they have also strong, let's say, African food systems based in West Africa on yams and cassava, and bringing to the forefront actually also local food systems to be complemented with trade. This is an element which we are pursuing in our EU-African Union partnership. So we are, let's say, linking the Sustainable Food Systems Partnership also to our international efforts. Then adapted logistic schemes are important so that actually there are no disruptions in supply chains, that are keeping the borders open, informing each other on the value of non-disrupted supply chains. Part of that is also digitalization of processes and food supply chains to reduce handling costs at the border, for example. Certainly all linked to responsible research and innovation schemes. Then change the way we connect with food systems. We need new tools and practices for improved consumer and citizen engagement in food system development. And it's interesting to note that similar to the ICT area, a lot of startups actually are existing in the food system. So often you see actually PhD students who have discovered interesting processes and they think about creating a startup around it. I think Oatly is a very prominent example of a PhD student in Sweden being so fascinated from the process actually they discovered that they created a startup around it. And we need, let's say, a culture which is actually beneficial for harvesting such ideas and bringing them in a startup culture to market. Then change the way we govern the food system. It's important that evidence is available that that decision makers actually have information available, and that we bring together such evidence, let's say science policy interfaces in member states into a network, into a context. We should also support the involvement of the plurality of food system actors and identify aspects restricting innovation and sustainability of the food system. And then briefly on the 4 interconnected activities. So pooling research and innovation resources and programming. 90% of all research and innovation funds in Europe are on member state and regional level. So we would like to offer the food system partnership as a tool of working together. Then launching a food system observatory, a European platform and network, and as assist decision makers and stakeholders. So to develop methods for assessment of food system sustainability using data and modeling. This is also linked to a food systems knowledge hub to link the different, let's say, knowledge hubs in member states and associated countries together. And knowledge sharing and scaling so that innovative solutions make it easier actually to the market and use opportunities for scaling up. The food systems partnership is inspired and closely linked to the Food 2030 approach, which we are pursuing since 2016 in research and innovation, where we have identified in our Horizon 2020 and Horizon Europe programming 10 areas of importance. And one of them is actually the microbiome world. And not only the coordination and support action, which we are benefiting today as, let's say, helping us to make this event happen, but quite a number of projects actually is funded under the heading Microbiome World, and you will hear more about it during the day. So the microbiome opportunities are an inspiration for the food systems partnership to achieve healthier, nutritious food products which are better for human health, cleaner for the environment, and offer opportunities for growth and job creation. And now a few words about, let's say, the mechanics of the food systems partnership. It was actually developed in a co-creation process. So we called in a workshop on the 18th September 2019 to all member states, which are, let's say, part of the Standing Committee on Agricultural Research, to nominate the best brains as drafters for a narrative of the food systems partnership. And this call on member states and stakeholders resulted in a group of 47 persons coming from many different backgrounds, which helped to draft the narrative of the partnership and also finally drafting the partnership template, which was submitted last December. And the narrative and a fact sheet are available. So they provide, let's say, the first substantial idea on how the food systems partnership would look like. The template, as I mentioned, was submitted end of December it was. And now the group of dedicated drafters is working towards a strategic research and innovation agenda, which will be the core building block actually to make the partnership happen. Such a Horizon Europe partnerships, as I mentioned, is actually based on a Commission contribution and co-funding by member states. It's implemented by we will launch a call actually, which will invite the consortium of the partnership to submit a proposal. So this call is expected to be published end of the year. And the co-funding of the Commission is around 30%. I don't want to go into more details, but also showing a bit the ecosystem of Horizon Europe partnerships and where the Partnership for Sustainable Food Systems is linking to. So it's linking to partnerships which are addressing, for example, circular bio-based Europe, which is linking to partnership on agriculture of data, to the partnership agroecology, and the partnership on biodiversity. So not to duplicate, but actually to set up linkages. And this is the this is the timeline. The group is now working on the strategic research and innovation agenda. When it is actually ready as a first draft in July this year, we expect actually to launch a public consultation. And as I mentioned, the overall funding of the partnership, if the Commission contribution and the member state contribution is actually realized, it could take up to 500 million until 2030, until the end of Horizon Europe, the Horizon Europe Research and Innovation Program. Thank you for your attention, and I want to give credit actually to the co-chairs of the SCAR Strategic Working Group Food Systems, Monique Axelot and Minna Hutunen, who were behind the co-drafting process, but also Hugo de Vries, who is with us today, Niels Halberg, Ivana Truklia, and the group of co-drafters were of the partnership template, which I have named here on the slide. Thank you for your attention.
Thanks ever so much, Hans-Jörg. And for those of you who are not keeping an eye on the chat, it's worthwhile doing, as a couple of links have been shared to documents and initiatives that Hans-Jörg mentioned during his talk. I will not be taking any questions at this point, so we are waiting until the end of the panel discussion to bring questions on board. However, if you do want to share any questions already, I will take a note of them and promise to bring them back in the panel discussion at a later stage, when we will have Hans-Jörg and all of the other speakers of this morning, plus some additional people available to answer any questions you may have.
Could I just mention, if the question comes, we will make the presentation available, but actually I've noted that there are still a number of smaller mistakes. For example, we have changed the title of the partnership from safe and sustainable just to sustainable, because sustainable includes safe, and I have to assure that on all slides the correct new title is used. Thank you.
So before we publish anything from our side, we'll double check with you again. Thanks a lot, Hans-Jörg. Okay, that brings me to our next speaker, which is Dr. Angela Sesic, who will be talking to us about the microbiome support pathway and why microbes matter for the Green Deal. Angela is the head of business unit at the Austrian Institute of Technology in Austria, and she is the microbiome support coordinator. She's a leading expert on beneficial plant microbe interaction and established a specific research area at the AIT in Austria. Her specific research interests are plant microbe interactions and molecular microbial ecology, and she's previously been a member of the ESFA panel on genetically modified organisms. Angela, over to you.
Yeah, good morning, everybody. Thank you very much for the introduction. So I'm very happy to be here today and to talk on behalf of the Microbiome Support Coordination and Support Action, and to say some words about microbiomes in the food systems. So let me start saying that microorganisms and microbiomes are everywhere. So they are throughout, in any ecosystems you can find diverse microbial communities. They inhabit soils, they inhabit plants, they inhabit all water bodies. You can find them in foods, you can find them associated with all types of organisms like animals, plants, humans, of course. You can find them in food spoilage, and so forth. As you will see later on, many of them or most of them are very important. But of course, there are also some ugly ones. As we know, we have some pathogens also included in our microbiomes. Now, microbiomes are also very important to reach the aims of the European Green Deal. They are key for providing fresh air, clean water. They are a key component of healthy soils, and they are, of course, a very important component of biodiversity. They contribute to healthy and affordable food. They are important for improving the sustainability of our production systems, but they also play an important role to provide or to enable food security, which is, again, becoming more and more important. So as such, because they play such an important role, as you will see, there is also huge potential for microbiome applications, and thereby they also promote future-proof jobs and skills, and generally contribute to the competitiveness of our industry. Now, let me say some words about different parts or components of food systems microbiomes. And let's start with soil and plant microbiomes. So we have thousands of species in a gram of soil, species of bacteria, of fungi, of archaea, of viruses. So a huge diversity which we can find in our soils, and also all plant parts are also colonized by diverse microorganisms, and they play important roles. They are the key for all nutrient cycling. So they degrade or any type of organic material contributing to the nutrient cycling. They provide nutrients to the plants. They contribute to a stabilization of soil structure. They're able to degrade contaminants. They're also relevant in terms of the uptake, but also the release of greenhouse gases. And they fight off plant diseases. They support plant stress resilience. So they have a huge role in maintaining ecosystem functionings of the soil, and also contribute to important plant traits like plant health, plant stress resilience, and play an important role in nutrient cycling. Also, animals are colonized by diverse microbiomes, and they have a very important role there as well. So some animals have special digestive systems, enabling them to degrade plant fibers. They also are key in all, again, in kind of metabolism. They control certain pathogens, and they play an effect on behavior and many diseases. Very important are microbiomes associated with humans, and you're probably all aware of the gut microbiome, but we also have skin, oral, etc. microbiomes. And overall, we consist of 10 times more microbial cells than human cells. So of course, these microorganisms play a key role interacting or acting as a kind of a special organ, interacting and contributing to the human metabolism. They help in the digestion, in the detoxification, delivery of vitamins, etc. So there are very important metabolic interactions going on in our body, and microbiomes play a key role here. And thereby they also prevent diseases. They have an effect on health, on aging, behavior, well-being, and so forth. Microbiomes in the food systems are not only complex, but they interact with each other, and they depend on each other. So for instance, microbiomes contribute to the primary production of plants, of animals, and influencing the primary production. They will influence also, for instance, greenhouse methane production in ruminants, or they will affect the quality of milk or of meat. And then, for instance, further on, if milk has a different composition and quality, this will affect storage maybe, or it will influence certain food production parameters. And this will again influence human health. Or also waste material can be degraded by microorganisms contributing to waste valorization, and this can be used for bioeconomy applications. There is a broad range of microbiome applications, and they can range from a broad band character to more precision treatments. And you see here on this picture just two major examples, one more related to medical applications and the other one more to agricultural applications, but they follow very similar principles. So for instance, we can just simply change our diet and thereby influence our human or our gut microbiome. Or if we look at the more crop production side, we can change soil management practices and thereby influence soil microbiomes and the functioning of soil microbiomes. But we can also have more specific applications. It can be either less complex microbiomes or strain combinations, or we can have very precision type applications consisting, for instance, of individual single strains. Now, let me talk about some examples of applications. And the first thing is that biofertilizers and biopesticides. I said already before that soil and plant microbiomes have very important functions for plant health, for stress resilience, and for nutrition. So we can use certain microorganisms or combinations of microorganisms, so also more complex microbiomes, to improve plant nutrition and to use them also as biological control agents, so to use them as biopesticides. So they have a huge potential to make crop production more sustainable, and thereby they have, of course, a huge benefit for food safety and quality and human health. Currently, applications are mostly based on individual strains. And there are some bottlenecks because we need to improve the efficacy, the shelf life, and the robustness of products. And by solving these challenges, we at the same time move towards a new generation of products, which integrates more advanced microbiome understanding, machine learning, artificial intelligence, plant breeding, precision farming. But for this, we need an adapted new regulatory system, because currently these kind of applications are squeezed into the existing regulatory systems based on chemical products. But this is not always suitable to really evaluate and to assess the risk or potential opportunities of microbiome-based products. We also have a number of applications, for instance, for the gut microbiome. They can be applied for the regulation of diseases. You can also use them for the development of new diagnostic systems, so using diagnostic markers based on the microbiome. There are more and more personalized treatments coming up, also personalized diets. And the main targets which are investigated currently, but there will be more targets coming up, are, for instance, asthma and allergy, or inflammatory bowel diseases, obesity, metabolic disorders. There are also more and more applications for the skin microbiome coming up. because microbiomes play also a very important role in the functioning of our skins. And here microbiomes can be used, for instance, to replace antibiotics, or they're used for certain medical and cosmetic skin treatments to improve skin functioning, and also personalized treatments are in development. Similarly, there are applications for the animal microbiome going very well in line with human developments. So microbiome applications for the regulation of diseases, for the development of diagnostics, and also here it is possible to develop customized treatments or customized nutrition. More advanced or more alternative approaches or more visionary approaches are also coming up to use microbiomes and their benefits to improve health and climates. And here you see, for instance, that by using plants, we can influence air quality, and the microbiome of the indoor and outdoor environment, for instance, reducing allergenic reactions, also having a beneficial effects on the climate. So there are more also visionary approaches coming up, making use of microbiomes. And last but not least, microbiomes are of course very important for food productions. So microbiomes are needed for the production and conservation of food. Think about the dairy industry, think about making bread, fermented food like sauerkraut, or fermented vegetables, fermented soya, but also coffee, beer, wine, chocolate. All here is always microbiomes are involved in the production of these food products. Now, we are still more in the beginning of developing microbiome products, and I would say we are still having first generation microbiome products. Now, to reach out to have the next generation products and to really exploit the full potential of microbiomes, we need more insight, we need more new suitable technologies to make use of these microbiomes. We need a microbiome-suited regulatory environment, and we also need a microbiome mindset to really make full use of microbiome applications. So what is needed to really exploit or make use of microbiome functions and the microbiome potential? And here I just listed needs ranging from more the research side to really more taking care that microbiome knowledge and applications can be taken up in our society. So on the one hand, we need more insight, we need more knowledge to really come up with knowledge-based solutions. We need, in regard to the protection of natural resources, we have to be aware that also microbiomes have to be protected. We always consider plants, insects, animals as a key component of protecting biodiversity, but also microorganisms are endangered to, or certain parts of the microbiomes are endangered to be extincted. We also need more international collaboration. We have to avoid the duplication and to really make better use of generated data, not only generated in Europe, but also in other parts of the world. There's a huge potential to make use of big data sciences, because microbiome data are big data, and they can be used in machine learning, in artificial intelligence, to be used for precision applications. We also need probably the development of new technologies and approaches to come up with smart microbiome fit applications. We also need realistic expectations, especially when it comes to time expectations. And we need a regulatory environment which is tailored to address potential risks of microbiomes, but which also enables a rapid approval and integration or application in practice. And overall, we need more microbiome literacy in the society and a mindset which is open for microbiome innovations. Thank you very much.
Thanks ever so much, Angela. So as before, if you do have any questions, feel free to put it into the chat. I'll make a note of it for the panel session. But for our next part, I would like to call on Dr. Emmanuel Magboy from the French National Institute for Agriculture, Food and Environment, who will be talking about what a healthy microbiome is with us. Emmanuel is the director of the Transdisciplinary Program on Microbial Ecosystems and Metaomics. She is the co-director of the INRAE Holoflux Meta Program and a co-coordinator of MicrobiomeSupport. She is active in microbial ecosystems in agriculture, food, animals, and humans, as well as industrial digesters and pathosystems. Emmanuel, over to you.
Thank you, Bettina, for those nice words. Let me see. Yeah. Do you see the presentation?
Yeah, we can see it well.
Okay. So, ladies and gentlemen, members of the parliament, I'm very happy to be here today and to share some information of what we know about healthy microbiome. And I'm going to use during this presentation, I will concentrate mostly on human microbiome, and then we will come back to more general aspects. So as you understood from previous talk, on Earth, all those living organisms have close association with microbes. We all have microbiomes, you know, from mosquitoes to human and tomatoes. And for the human body, microbiomes or microbes are present on all the surface of our body, which are exposed to the environment. So we have microbes on our skins, on our respiratory, gastrointestinal, and urogenital systems. According to the location, the microbiomes and the microbe species which are present are different. But altogether, the number of microbes associated to our body equals the number of human cells which constitute this body. So in fact, we may have to consider that we're not only human, but we are also partly microbial. For the microbe point of view, our body is a very nice place to be there. It's sheltered. They're not exposed to too many predators. And food is provided very regularly. So, nice place. If we consider the human point of view, it's also nice and important to have this microbiota. They are strengthening the mucosa. They are making our barriers more strong. They protect against pathogen. They educate and support our immune system all lifelong. And they use food that we don't digest to feed themselves, but also to synthesize and to provide essential components, such as vitamins, but also small molecules, metabolites that really communicate, signal, interact with our human cells. And those type of molecules not only are active and communicate with cells locally, which are present locally, but they also connect with remote organs, such as the brain or the lung or the skin. So this interaction is clearly beneficial to both partners. We are talking about a symbiosis. And it's clear that for each partner, they have much to lose if this symbiosis no longer works. So defining healthy microbiome can help to monitor the state of the symbiosis and can help to prevent or to correct dysfunctions of the symbiosis. However, it's not easy because the microbiome is changing with age. You know, from babies to adulthood, we are building the diversity and the complexity of the microbiome, that it remains more or less constant, and with age, it's declining again, and we see an increase of pathobionts. Pathobionts are present in the microbiome. They are opportunistic pathogens. So we have to take into account the age and sex of the person. But there is also other factors which are shaping our microbiome: birth condition, diet, the history of medical treatments, including antibiotics, but not only, exposure to the environment, and so on. And it's why also all those factors only explain 20% of the variability of microbiome. It explains why each of us have a different microbiome. And it's why you can see here with those colors representing big groups of microbes. And you see that from between individual A and B or E, the proportion, the microorganisms which are present are different. So it's not a question of one healthy microbiome, but it's a question of several healthy microbiome and of inter-individual variation. And what I told so far as consequences, it calls for treatments which consider not only the host, but the host and the associated microbes. It calls for personalization of diet, of dietary intervention, and of therapy, of therapeutic treatments. And it highlights, on a scientific point of view, the need to better set the references of what are the healthy microbiomes. However, we already have lots of information, and Fergus Shanahan last year compared all the data which are available on microbiomes. And what he found out is that we have these clear differences between industrialized microbiome for people coming from industrialized country and people from non-industrialized country. And it correlates with the challenge we meet in industrialized country, which is the rise of non-communicable chronic illness, such as metabolic disease, cardiovascular disease, respiratory disease, cancer, with the prediction of World Health Organization that by 2025, which is tomorrow, 1 human in 4 will suffer from one of these diseases. What happened in our country? In fact, we changed so many parameters which are shaping the microbiome that it's not surprising that we modified it. Birth condition changed a lot. Diet changed a lot. We have much more medical treatment during our life. We do less exercise and so on. And we also change the food system with more chemical input, with more industrialized and highly transformed product, with lower diversity in products and in microbes, which are coming from the food system. We know now that many of the these changing are impacting our microbial part. And if we want to represent that, we can imagine a healthy microbiome as a tropical forest with so many species interacting, complementing each other's. And what happened probably in our industrialized country is that we put this nice system under repeated small stresses. And little by little, we are compromising the species diversity. We have less interaction. We are losing some function which are important for our body. And more important, the microbiome progressively lose its capacity to recover from stress and to go back to the initial state. And then at some point, we reach a tipping point where a stress really lead to a massive degradation of the microbiome, with a rupture of the symbiosis and an unhealthy vicious circle which is establishing, with a rupture of the symbiosis, more pathobionts, more inflammations, more oxidative stress, and conditions that are really difficult to break down. So there is a need to detect and prevent this deterioration and to be able to restore healthy microbiome when it's really compromised. Regarding prevention, we really have to reconsider our lifestyle and to reduce the number and the importance of stress that we put on our microbiome. One of the easiest but also important aspect is to consider our diet and food system. Diet is a source of feed for the microbiome. It's a source of microbes, with some of them being probiotics, meaning that they bring positive, beneficial functions. We need to eat more fibers because microbiome love fibers. We need to diversify, and it's recommended to eat 25 different vegetables and fruit per week. And we have to consider also our difference, our variability, and be ready to go for personalized diets. Now, what we know is that it's difficult because the determinants that will bring consumer to change behavior are unknown, are difficult to mobilize. So main aspect is education, is learning good habits from the start and keep it all life long. Then regarding restoration, most of laboratories have what we call discovery pipeline, in different therapeutic areas to identify microbes and candidates for therapy and microbes application. They might be single combination of microbes. They might be fecal microbe transplant. They might be bioactive compound produced by some of the microorganisms present in the microbiome, and so on. What is important is that it's not only microbiome, it's only microbiome and host. So we can use those innovations, but we can also use them and combine them with drugs which are already existing and which target host physiology, or to combine them with lifestyle intervention and consider how to improve our system to facilitate long-term maintenance of healthy state. So, healthy microbiome, from that, what can we say? Diversity matters. We are hosting in our gut, let's say 400 bacterial species in our intestine, including pathobionts. And it's important to have this level of diversity. And pathobionts also have beneficial role in some condition. We need this complexity to have microbes which connect to each other, which interact to each other, as it is represented here in those interaction networks, because those two conditions will help our microbiome to be resilient, meaning that they can be put under stress and recover from the stress and go back to the healthy situation instead of degrading. And this definition, those considerations are not only true for humans, they are true for all living organisms. We have to think global. We have to consider systems, If we look at food systems, the spreading of antimicrobial resistance genes and resistance microorganisms, food intoxication that we can get from time to time from our food system, are examples showing that microbiome there is microbial flows in those systems, you know? And we now have means to consider how to increase the healthiness and efficiency of microbiome, which are associated with different steps and different living organisms of the system. This would mean less chemical treatment, less chemical input, lower antibiotic resistance and lower resistance to other types of chemicals, more diversity in food and more diversity of microorganisms bring by food and more sustainability. And humans, as an end consumer of the system, is going to integrate all those benefits. To conclude, microbiome science is still quite recent compared to other fields of science, but it changed already several paradigms. What we know is that human health results also from an active symbiosis between our human cells, human part, and the microbial cells which are associated to our body, which are talking to our body. So it means that treatments, intervention can target and should target both. They should be beneficial to the symbiosis, you know? And in terms of prospect, for scientists, we still need to better define our references, advanced understanding of the symbiotic mechanisms. In terms of knowledge, we know that we are different. We don't have the same microbiome. We have various individual situations, or there is groups of people. So we have to forget the idea that one solution, one size will fit all. We are diverse and we need to, and it's why we require personalization of solution, both for diets, but also for medicines. And for science, we have to identify the relevant biomarker to stratify the population and data science to predict the response of this population to intervention. As Angela Cecile showed you, and as I mentioned, there is already a wealth of approaches of microbiome application for human and beyond for food systems. We have to reconsider the assessment of benefit risk. Microbes are not only pathogen, microbes can be beneficial. And we have to support this new economy in which Europe really invested in terms of research. Regarding prospect or regarding the scientific aspect, we have the skills, the scientific community exists. We are ready to work with regulatory agencies. And we are ready also, we are really keen of doing responsible research on those aspects. So we just have to use it. And I just want to thank you for your attention.
Thank you very much, Emmanuel, for introducing us to the healthy microbiome and what it might be and the different variations of it. We are now coming to the part of the morning where we're starting our first panel discussion. So I would like to call our three speakers from this morning back on camera, in addition to the MEP, Mr. Herbert Dorfmann, the MEP and Dr. Josas Olekas, as well as Professor Yolanda Sanz. And we're going to allow the newcomers this morning the first word. Specifically, I'll be starting with Mr. Herbert Dorfmann, who is a member of the European People's Party, an agronomist by education, and probably not surprisingly, a member of the Committee on Agriculture and Rural Development. He also holds the position of being a co-rapporteur for the initiative report on the Farm to Fork strategy. Welcome, Mr. Dorfmann, this morning. And I'm going to give you the floor to just give your perspective on the talks that we have heard this morning any considerations that you may want to add to it and any additional comments that you might want to introduce before we start into the broader panel discussion at large.
Yeah, good morning. Thank you very much for giving me this opportunity this morning. Yes, indeed, I was one of the rapporteurs together with my colleague Anja Hasekam on the Farm to Fork strategy. And I think on the basis of all of nutrition, there is for sure farming, and we have a lot of talks in this moment about sustainability, also this morning about sustainability in farming, and I remain convinced that sustainability has different let's say elements. There is for sure the need of an ecological sustainability, but if we want to go on for farming in Europe, we need at the same time also an economical sustainability and the social sustainability in farming. So we need this combination of ecology, of economic sustainable farming and social sustainable farming. And to achieve this, I'm convinced that we need to invest in research, we need to invest in knowledge to go a step further. And once we get new technology, we get new knowledge, we need to make this knowledge available. And this is not that easy, because one thing is to have the research done and the knowledge available. The other thing is to have it on the ground, have it at the farmers in the farms. And to have this, there is very often a cost problem. A lot of technology costs, and there's an advisory problem. So we need to distribute this knowledge from the research institute to the farmer. And there's also an urgent need, I think, to have young people into farming, because it's clear that innovation is very much linked with young people open for innovation. And therefore, I personally think we need a more positive storytelling about farming. I'm living here in this situation in Brussels, and I hear a lot of people going on to criticize farmers. Very often people who never have been on a field for 1 hour in their life, but they go on to criticize farmers. And I think if we want to attract people, young people, into this farming world, we need a more positive storytelling. This does not mean that we say everything is perfect, but we need to explain to young people the opportunities they have in farming, and we need overall a positive approach to farming. And I think also that we need a balance between sustainability on one side and production on the other side. I've been here for quite a while now in Brussels since 2009, and I remember in, let's say, till 2015, 2016, we spoke a lot about sustainable intensification. And we lost completely now in the last years this approach. And I remain convinced that we need, if it comes to production of food, we need to achieve at the same time a ecological sustainable production, but we need to remain also intensive. And these days, the war in Ukraine, unfortunately, tells us how dependent we are on a lot of crops from import from outside Europe. And this is not only proteins, because on proteins we are speaking since a lot of time here, but it's also on wheat, it's on sunflower and other crops. And we need to have, it doesn't make sense to say, okay, we are highly sustainable in Europe and we export part of our food production and part of our CO2 emissions in other parts of the world. And to achieve all this, I think we need on one side to have clear targets where we want to become better, reduce pesticides, reduce fertilizers. And on the other side, we need to have a way to do this. And this needs to come at the same time. We need to give to the farmers new technology which allows them to reduce And I think the debate we have today on microbiomes and the possibility of microbiology is an extremely important element of this, because it can contribute to reduction targets. And we need also other elements, like, for example, new breeding technology and others which allow us to come to this reduction target. But we cannot have on one side only reduction targets without at the same time having also clear ways and clear technology available for farmers in order to achieve this. And I think this is the challenge of the next years.
Thank you very much for that brief introduction and the thoughts from your side. So what I've heard is, and I think very much from at least the scientists that I work with, there is this acknowledgement, yes, we need to communicate our work much better than we currently do, make it much more practically available also. But as the co-rapporteur for the initiative report on the farm to fork strategy, do you feel that microbiome researchers could also expect more from policymakers to help facilitate that?
Yes, for sure. I think it's an important element of the whole debate, because, and I think this is the, let's say, this is the good part of the farm to fork strategy, at least the intent of the farm to fork strategy, to see nutrition policy not only as a farming policy, but as a policy which starts in the field and ends at the nutrition of the people. Then I honestly think that the farm to fork strategy widely failed this objective, because it speaks a lot about farming and it doesn't speak a lot about what happens after farming. So it remains a bit a farm strategy. But I think the idea to say, let's see the whole sector from the farm to the fork, and the microbiome is a very important element of the fork elements of the nutrition and quality of nutrition. I think this is an important and I think also an appropriate approach.
Great, thanks very much. So I'm going to pass on to MEP and Dr. Josas Olekas now, who is a member of the Socialists and Democrats Alliance. He is also a member of the Committee on Agriculture and Rural Development, in short, AGRI. Professionally, he has been working in medicine, particularly as a doctor or surgeon, for a large part of his life, and has, amongst others, also served as a health minister in Lithuania and as a minister of national defense. So what is it that you would like to contribute to the discussion this morning?
Thank you, Bettina, dear colleagues and friends. Thank you for inviting me to this event to discuss the essential role that research plays in modern food systems. It is a very important topic and very near to my own heart. As you said, I'm a medical doctor by profession, so I know firsthand the great benefits science can give us. Today, I would like to focus my remarks on food security, which is an essential issue these days. We are all shocked, although maybe some of us are not surprised by the war Russia is now waging against Ukraine. This war has the potential to impact global food security. 71% of Ukrainian territory is agricultural land. Russians and Ukraine export together account for about 12% of the world's calories. Both countries together make up 25% of world wheat export. At the same time, the COVID pandemic has already affected supply chain and increased global food prices. FAO food price index in February averaged 140 points, 20% more than a year ago. Climate change has caused historical droughts in North Africa, South America, United States. We are facing a global crisis of food security. This was mentioned yesterday by United Nations General Secretary. This is why the recession to food, environment, soil and health is so important. Innovation is especially important in agriculture sector. It plays a key role in feeding the world population, adapting to climate change and protecting natural resources. We as lawmakers must work fast and make science-based decisions to integrate well-researched and safe new technologies into our policies and life. We must find new and modern problems in new and modern ways. Properly researched, developed and applied technologies can be a great help facing both to old problems and new challenges. As Herbert said, I think we need to cooperate our efforts to create a public opinion, positive public opinion about the implementation of research knowledge to our daily life. Thank you very much.
Thank you very much, Jusas. So with your hands-on experience as a doctor and surgeon, and knowing that the food system microbiome has a very large potential for public health, whether it's from a personal health perspective, whether it's from a food safety perspective, how and where do you see opportunities for better exchange between research and policy in an effort to deliver the European Green Deal goals jointly?
As I finish my intervention, I think it's very important to create the joint or common opinion between the policymakers, researchers, and have a support from the public, because it's a lot of cases when we have a very high level achievements by researchers, but it's very difficult to implement in practice to have the support. It was in the COVID pandemic, vaccination. Look how much we can against anti-vaxxer movement, how strong it was. The same in the food sector, because we need enough healthy food, and we have for that new innovations. Microbiome is also one of this, and this need to be with support of public.
Great, thank you very much. And I think many of us will agree with you on gaining public trust much more again by starting to talk to people early on about the type of research that we're doing. Thank you. So it's my pleasure then to introduce Professor Yolanda Sanz from the National Research Council in Spain. She is a principal investigator of the research unit on microbial ecology, nutrition and health. And her scientific field of interest is the influence of the interactions between the gut microbiota and the diet on human health and diseases related to metabolism and immunity. Yolanda, what would you like to bring to this morning's conversation?
Well, first, I want to thank you and also express my gratitude to be here with such excellent speakers. And well, from my perspective that I work on the scientific field and also on the regulatory area as part of the different EFSA panels, I think that's important that from the scientific field, we start filling knowledge gaps that are necessary to ground new regulatory instruments to evaluate the effects of different foods and chemical agents on the microbiomes. I think that this is crucial. If we admit that the microbiomes are part of our biology and influence all of our physiological functions, from metabolism to immunity to the way we think, to our mood, we should find a way to evaluate how we can quantify which alterations in the microbiome are beneficial or are adverse. In such a way, we can do this risk-benefit assessment, and on this basis, set the criteria, the scientific criteria to evaluate the products that can reach the market. And I think this is an important knowledge gaps that links with the lack of clear regulatory path for the approval of these products. And in this context, EFSA has already taken action to screen which is the evidence and how to address this knowledge gap and how to find a way to establish standards. But in this context, to do these measures, to do these assessments, but in this context, probably we will need also the partnership between science and industry, and also the participation of organizations as OECD that are involved in establishing these regulatory instruments. And I think this is quite important. Another aspect that has already been mentioned is our progress towards the use of personalized solutions, not only in the nutritional field, but also in the medical field. We have to consider that each person is unique, and also it has been shown that our microbiomes are unique. So we have to change also this paradigm, and this has implications in the way we evaluate the efficacy of foods or medicines on different human conditions, because we have to progress from the typical evaluation where we try to see the effects on general population to evaluate effects on an individual basis. And this means to establish changes in the criteria we apply to evaluate clinical trials. I think this is also a very important point to progress towards the approval of such personalized applications that can lie in the field of foods and nutrition and can lie also in the field of medicines. And I think these are perhaps the critical points that are very close to human health and nutritional solutions, but can also be applicable to other fields like improving animal health, welfare, productivity, and also the health of the soil and the health of the planet. We have to move from this traditional way of assessing risks and benefits to a much more modern way of doing it, taking into account multi-criteria approaches and also this ecological perspective. So the effects are not depending only on one microbe or one strain, will impact on the whole ecosystem. This means on this network of communication between the different microorganisms that are part of this ecosystem. And we need to include this ecological perspective in these assessments.
Thanks very much, Yolanda. I think that was really nicely added perspective to when we are opening in a moment to the broader discussion at large. Is there anything that you would like to add to the expectations that have been outlined so far by the different presenters towards policymakers that are delivering on the European Green Deal, seeing that we are talking within this session on mutual expectation towards each other?
Well, I think it's important to increase the dialogue between the two sides, the scientists and the regulatory bodies and the policymakers. This can be done in different forms, organizing meetings, workshops, exchanging the information that is coming out from the different projects. I think this has been put in place already in many of the initiatives. So I think we are progressing in the right direction in this sense. It's time there is more involvement of regulatory agencies and policymakers in scientific projects, not direct involvement, because this will mean conflict of interest, but indirectly in the sense that they start participating in the meetings we have during the course of the project. And this is already very, very important and very good news. We are organizing already many workshops and events together. This is a very good start point. And I think that these actions that, for example, EFSA is launching, involving scientists to bring evidence on aspects that affect regulatory science. So it's the scientific knowledge that is needed to apply scientific criteria to regulated products. I think that are also very important to close this gap between what is done in science and what is done in the regulatory context and the real life. And in this area, I think it's also very important to do more educational activities in a way that we train also those that are going to be the future scientists at universities in the regulatory aspects. Because it's often the case that people are not only at university level, but starting doing a PhD without having any knowledge at all about the regulatory context in which they are in fact working to some extent. And I think if we go in parallel in the two directions and we include regulatory aspects in educational programs, all these young scientists will start doing science with this perspective in mind, with the idea that all this research they are generating, all this knowledge they are generating should finally be applied, at least in part. So if they take into account the regulatory context in the way, it will be much more likely that the results are finally used by the society and the productive sector.
Great, thanks very much. I very much hear you on bringing in the more practical aspect in what you've just spoken about, particularly the regulatory aspect in education, so that scientists that are working in the labs, that scientists that are working in the fields really also understand the practical conditions of how their research will be used in practice at a later stage. So thank you for bringing this in. And in the meantime, I've also started receiving the first questions. Please feel free, anyone, if you do have a question, share them in the chat, I'll pick them up. But this very first one, Hans-Jörg, I believe is most relevant for you. And specifically, it's about the Sustainable Food System Partnership, which connects research from food processing to plate. But how will the Sustainable Food System Partnership connect with other partnerships to cover the whole food chain, especially in relation to microbiome research? And in addition, how to include microbiome research innovation from farm to fork using a system approach via the partnerships, for instance, by using less chemical inputs in primary production, and how that affects the whole food system.
Yes, thank you very much. It's an excellent question. I'm happy to respond. I focused on the food systems partnership, but there are 4 partnerships currently in Cluster 6, Horizon Europe, which have been co-created by the Standing Committee on Agricultural Research Groups. Farming transition agroecology is one of them, focusing on primary production and bringing also the potential of microbiome concerning soil fertility, soil protection, but also perfect use of fertilizer inputs for the plant into context. The Horizon Europe Partnership on Animal Health and Welfare, agriculture of data. So these are partnerships which are co-created in parallel. And for all partnerships, member states receive today a letter for co-funding. And this would be my plea, stand strong and firm when it comes to funding of research and innovation. You can't switch it off, let's say, in one period and then expect that results will be available when you need them. I think the RNR technology has shown that many years of investment in rather basic science, then also applied science, and RNA technology was exactly actually ripe and available when the first quick vaccine was needed. And in agriculture and food, we are developing also concepts which are actually ripe when we need them. One of the concepts, and I would relate to Herbert Dorfmann's excellent input on how is actually research and innovation delivered on farm. The Standing Committee on Agricultural Research had an expert group on agriculture knowledge and innovation systems starting back in 2012. And they developed this interactive learning concept, bringing farmers, researchers, advisors into operational groups, into groups actually which solve problems farmers have in the field. And this developed further into the European Innovation Partnership, Sustainable Agriculture, which is now broadly rolled out in the second pillar of the Common Agricultural Policy. So in this CAP strategic plans, all member states are asked to fill in this AKIS, Agriculture Knowledge and Innovation System chapter, to allow even more than the 3,000 operational groups which are now working under the EIP Agri to be active in the field. And this means solutions for apple growers who want to reduce pesticides, solutions for vegetable growers. But I think what we still need to add to this EIP Agri is the nutrition dimension, so that we also bring in consumers and citizens. And this is also one of the elements of the Sustainable Food Systems Partnership. We want to work also on local level. So we want to work with, let's say, living labs, with lighthouses, and in close collaboration with the other partnerships to bring in citizens in a common, let's say, learning exercise, also bringing in doctors. Why not having an operational group which is based on maybe diabetes 2 patients who are actually want to change their nutritional behavior, working maybe with local farming community to deliver directly vegetable boxes to them. So I think there are many opportunities of linking producers and consumers, and maybe also in a renewed EIP concept. Thank you.
Thanks very much, Hans-Jörg. Indeed, I think there are also, from your earlier pitch on what you mentioned in terms of the different cluster 6 partnerships, quite a few that might already really work towards that link that we want to establish between different scientists talking to those people who will in the end make use of the science somehow. And in a way, it's asking of us to be able to explain very well what we are doing and why we are doing it, to also listen and understand the specific environment in which solutions are needed, and then within a co-creative approach, really try and find solutions that work on the field, on the farm, in the hospitals, within a doctor's environment, within the supermarkets, and the kind of education that we bring to people, whether it's about nutrition, whether it's about the kind of choices that we make when we are in supermarkets. Thanks. I'm going to pick up on something that has come up quite a lot this morning, and this is like this personalized approach when it comes to the microbiome. I think we've heard a lot about the personalized approach in human health, but what I'd like someone to consider is this also applicable in other environments? If we look at the food systems microbiome. And Angela, knowing your passion for soil, I'm going to ask you to maybe speak a little bit on, is a personalized approach, for instance, also feasible in a soil environment? Does it make sense? And maybe you can even also expand into the plant environment, particularly crop, vegetable, plants or fruit, all of that basically provides healthy nutrition to us.
Yeah, thank you, Bettina. That's a very interesting question. We have not thought really in terms of on a individualized approach, but of course it's very difficult to really assess soil quality. Of course, on the one hand, we see it more from a human point of view. What is soil quality, for which value does it have for crop production, for instance? But so it could be, it could be seen, or it should be probably also seen on a more individual basis. So to say, to get away from this black and white thinking. Yeah. So it can be that, for instance, you have a soil with a certain microbiome, which is suited for certain purposes, or which has certain potentials, and we can make use of this potential. So maybe one soil is better to produce carrots, but another soil is maybe better to produce wheat. Yeah? Just, I mean, to make it clear with a simple example. So I think from this point of view, big data and machine learning and precision farming will play a more important role. So we can also use microbiome characteristics together with other parameters as predictors in terms of what is the best farming practice, what is the best crop to be used, maybe even what is the best genotype to be used. Yeah? So I think there are a number of things which play together, including the microbiome being an important component, which can steer certain practices and approaches. And this would be then this individualized approach. I would like maybe may I just add a short comment on what was previously said. I think there's also a very important direction coming up, for instance, in the soil mission, so that we see soils from different points of view. Of course, it's important for ecosystem functioning, it's important for crop production, but it's also, we should see more and more the link between, let's say, soil microbiomes, between soil quality and food quality. So not only in terms of yields and sustainable production and fertilizer or pesticide input, but also which quality does the food product have as a result from a certain soil quality. So I think also this link between soil quality, soil health, and food quality, I think that's also an important component.
Thank you. And I'm going to follow up with that with a little question, actually, Angela. How do you feel public trust by farmers, not necessarily public trust, but trust by farmers, by food producers, actually comes into play once we are ready to give them microbiome applications that they can deploy? Do you think that's going to be an issue? What can we do to consider potential hurdles?
Yeah, I think that's a very important question, because we don't want to run into the same problem as we had with GMO applications. We generally, I mean, often microorganisms are seen as negative, as pathogens, as problem producers. Yeah. And so I think on the one hand, we have to increase microbiome literacy, and people have to be more aware about the importance of microorganisms in different systems for our health, for the environmental health, and so forth. So that's one part. And then I think we have to discuss very openly, and we have to be open in terms of, okay, are there risks? And if there are risks, we have to discuss them, we have to address them, of course. And we also have to discuss about the potentials. And so I think we need more really discussion also in the public space. And for this, we also need more knowledge and literacy about microorganisms and microbiomes.
Thanks very much, Angela. And following on this public trust issue, Josas, I'm going to come back to you and say we're going to be ready one day beyond fecal microbiota transfers to offer microbiome applications in a therapeutic setting, whether it's on a hospital level or in a doctor's practice level. what role do you feel clinicians and doctors have in helping to increase public trust towards potential microbiome applications? You are muted still.
I think this is a very important social group, medical doctors, nurses, because they have very close relation with the patients and with our citizens. And if they explain them in very practical manners, in very close way with having the close contact, I think it's really very important. The same as all other good behaviors, good food, healthy lifestyle, everything. The you example for this is for regarding the patients and especially for children. This is in every family. They follow the examples of some kind of leaders, and I think in the small societies like rural areas, the medical doctor or nurses, he or she is very important leader or example of way of life. And in this situation, I think that the role of not only the doctor but medical staff, I think it's a really very, very important one.
Thanks very much, Justus. Emmanuel, I saw you unmuting, so I was wondering whether you had any additions to it.
Yeah, I fully agree with the comment. I think it's a very important profession to consider. All those people working in the field of health, those health professionals, because they have this close contact with patients, and because for patients their opinion, their advice are very important. And you know, we mentioned already education, and I have to say that education in that field is also important, because for example, in France, medical doctors, they got 2 hours of teaching on microbiome. And I think they need more if you want medicine to really understand that you should take into account the human cells, but also the microbial cells when you do a treatment or when you accompany, when you go with the patient. They need to know more on that. So we are trying to push for that. And on the other side, what is interesting is that, you know, for general biology teaching, for adolescents, for youngers, they already have microbiome in their books to learn. So I think it will change, but we really have to make the effort and to consider, you know, that we should also really explain the knowledge to all the people, including health professionals. It's very important. Yeah.
Thanks very much, Emmanuel. I'm keeping my eye on time. So the last question for this particular session that I would like to put forward is a question on political incentives. And Helvan, I was wondering whether I can address this to you. Do you think they would make sense in context of microbiome applications in different fields of the food system? So essentially making sure that microbiome applications are adopted by those people who can use them, whether it's on the field, whether it's for therapeutic processes, whether it's for nutrition education, for instance.
Yeah, I think there are 2 elements. One is that for sure, if we have new technology and new knowledge, but this is not only on microbiomes, this is all over the whole process, we need to support it because otherwise they do not have a chance. And support means it can be a financial support, but also political support. For example, in the application process or in the authorization process, which very often on new technology is very long. So this creates huge problem for who is working on the topic. And then I think on a broader perspective, microbiomes, as we said this morning, are very much connected with nutrition. And on nutrition, there is on one side the education question. So am I able to tell to people what they should eat and how they should combine their nutrition? This is for sure an important topic, but then it comes also to pricing. And if people go to the supermarket and they decide what they want to buy to eat, very often they lack information, and this is a labeling problem or question, or it is a pricing problem and or pricing question. And if surprisingly 1 kilo of meat has the same price as 1 kilo of vegetables, it is quite clear that consumers take certain decisions which maybe for the microbiome and for the nutrition and for our climate are not the best ones. So and here we need to see how we support different, let's say, production in agriculture in order to invest in a more healthy nutrition. And this is also a big responsibility, I think, of the supply chain, because unfortunately today the supermarkets make a huge profit on products which for the microbiome and for the nutrition would be very helpful, so on fruit and vegetables. And this is unacceptable. And this brings at the end that the pricing in the supermarket, which very often is simply unhealthy.
Thanks for that perspective. European and Mediterranean affairs concerning sustainable food and bioeconomy systems. He is also the president of the European Federation of Food Science and Technology, actively involved in, for instance, the SCAR and SAPEA working groups on sustainable food systems, the FAO-led International Sustainable Bioeconomy Working Group, and the EU-funded Coordination and Support Action Fit for Food 2030 and Food Force. So, Hugo, if we've got you here, over to you.
Yes, good morning, Bettina. Good morning to you all. And first of all, many, many thanks for the invitation. Can you hear me well? Very well. Okay. Then I keep it like this. I'm still playing my role as astronaut here in and food in the Interstellar Space Station is very important. So we can stick to that topic or maybe go back to the partnership, which I think is the topic for this morning. I'm also highly or positively astonished by the enormous interest for this topic, which is one of the most complex, but on the other hand, one of the most important topics also for food systems, for their functioning, but also for what they can bring to people and their health, as already said by the excellent speakers this morning. Hans-Jörg gave a fantastic presentation about the partnership this morning. So nearly I was thinking I give you 50 minutes extra coffee break, but I'm not going to do that because I like to add some complementary remarks to what he has already presented. I'm going to try to do that by sharing my screen. And hopefully that works.
Yeah, we can see it. It's not quite in.
Can you see it now?
Perfect.
Perfect. Okay. Thanks a lot. So I will continue what Hans-Jörg has been explaining this morning about the Food Systems Partnership for People, Planet and Climate. And of course, I'm just one in a large group of people who contributed to it. So I put a wide background. If I should have added all the logos of all people's organization, then it was too fully covered. So it is really work of a wonderful group of colleagues in many, many different disciplines with different competences and different professions. So we are very happy with that. In fact, Hans-Jörg's explanation of the partnership was based on there are really needs. The why question is very clearly addressed. Why do we need a partnership? that is presented here on the left. There is also quite some evidence that we need to take action now. That is written in many different reports by different organizations from different angles, from a more nutrition point of view, from a climate point of view, from a biodiversity point of view, etc. And thus there is also a need for action. And this action, the European Commission, together with the SCAR Strategic Working Group on Food System, has taken the initiative, as Hans-Jörg said, in September already of 2019, to start working with a group with different experts to first prepare a narrative about a partnership. What do we like to reach as a partnership? And why is that necessary? And how are we going to do that without forgetting people that can play a key role? And of course, not forgetting at all what the citizens really need. Not only in terms of their nutritional request, but also in terms of affordability that we sometimes forgot. And that is also, and I was very happy about the point about food security. It's becoming really a key issue today for many, many people around the globe. So there are many reasons that actions are needed and actions are undertaken. For the partnership itself, there were also several gaps to be filled. These are mentioned here. Of course, it is such a wide area. Can we develop a common food strategy? That's the first question, which also respects not only the topics that we like to handle at the European level, but also all the different local topics, respecting local food cultures and their needs. Is there a kind of coordination possible that is now today called inclusive, where all kinds of players at all different levels can work together in a very effective networking way? So also that we are not only dealing with issues in production, as rightly said this morning, but we need to connect them what's taking place after harvest. We should not forget logistic, distribution, marketing, not the consumption phases, neither recycling. So are we then able to network between all those players? And also we there have to realize that we cannot network with all people. That is one of the maybe most fundamental issues if we are talking about food systems or systems in general. The complexity of systems, if we like to interact with all people, with many, many different peoples, is becoming so high that we enter a chaotic situation. It is like at a party, if we are with many, many different guests and we are all speaking with each other, we cannot hear each other anymore. What we say is not understood, what they respond is not understood, it's a chaos. On the other hand, if we are sitting in isolation and all work in our disciplines, like at a party, we are all sitting in a circle and don't say a word to each other, it's a highly dead party. We're in a frozen state. That is also not the idea. We somewhere need to network at the edge such that what we can do also brings something and is put into practice. And people in neurophysiology say that as human beings, our brains are made or formed in such a way that we effectively can work with about 150 people. But luckily, we are not alone. If all those people can do it, then we can really network and form clusters and jointly act. The market uptake of research and innovation is a key topic. Of course, we should not forget that we have the EIT Food in place, who is doing wonderful work in innovation. Current food surveillance systems, we often work still in different parts of the food systems. Can we connect what we learn in agriculture with what is taking place after harvest? And can we connect data in a sensible way? Citizens' access, as said in the beginning, very important. And food system knowledge and approaches. There also we need to do something. Those were the starting points for creating a CSA, and a CSA is in this case, I will say a word in the next slide, trying to build a system like this. Here it is presented like a bird surrounded by other birds that are the other partnerships, trying to understand what's taking place around us with all the challenges that we face, observe them, learn, and steer then our course based on what we have learned from case studies, what we have learned in research and innovation trajectories, and what we have learned in the policy domain, including the regulatory domain, as said this morning, key issue. If you are able to combine all this information, then this bird may fly in the right direction. And together with the other birds, we hopefully enter then a sustainable area for our food systems. So this is the basic thinking of our CSA, which is going to build a prototype partnership. So not the huge one that Hans-Jörg mentioned, the over 500 million euro initiative. This is a much smaller initiative, but it is meant to build a prototype which symbolizes the way the future partnership can work. It is a response to a call with 17 partners representing 18 networks. And that is, I think, also a very positive point of this consortium, that it has partners and networks at the local level, community level, like the Milan Food Pact or the e-client networks, at the regional level, the area of networks, national levels with funding agencies and ministries, even at the global level with the One Planet Network and the FAO. So we are covering the different skills, and we are covering the different kind of stakeholder groups, from farmers, the industrial parties, but also the NGOs, the philanthropic organizations, the European Food Foundations organizations, etc. We hope with that we are able to get the voice of many people and their best knowledge and suggestions how to construct this partnership. And it has 4 main focus points. First, it needs to develop this governance model where we can really listen, understand, and work together with the different stakeholders. So it should be inclusive, and it should be in a network kind of way operating, not only in Europe. Of course, in Europe, very important to get the voices also of the local communities, but also at the global level, that our trade-offs are not impacting in a negative way initiatives in Africa and Latin America or where else. So we like to work really with networks of networks to see the impact of what we are doing and learn from each other. Co-creation, Hans-Jörg has used the term several times. What does it mean? I come back to that. And system approaches, I also come back to that. Co-creation, that is a key topic in food passes. How is that explained? If you look at management literature, I'm a basic physicist, so my knowledge about the microbiome is limited. My knowledge about management is limited, even though I've tried to learn a little bit on my way now to where I am, what they tell me. And in management literature, there is something very clearly stated. If you're starting an enterprise, or as a farmer, you start your job, there is an area, a very huge area around you where you have to appreciate what's taking place. These are the huge challenges. Maybe you are like a colibri who can influence, but it's nearly negligible. But then there is an area which is smaller, but where you have at least the impact to have an influence on this environment by the actions that you are undertaking. And then there is an area where you have control over your own business, or about the policy measures in your community, or what else. It's an area of control. And then there is popping up something relatively new, and that is the co-creation, which is in between control and influence. And why is it so important? If you're able with others, and that is depicted here, in the core, you have your business in control. But if you are able to form clusters with other actors, you can enlarge your spectrum and have a larger influence on your environment, and then also hopefully a larger positive influence on your environment. And then if you are able to do that, you are also more closer to the challenges that you are facing with, and hopefully can contribute with something more sensible. So from a more individual towards a more collective approach makes sense. But that has also enormous impacts on your own functioning. You are going to share responsibilities. You are confronted with what you do and taken by others, and the outcomes of that also for your own business. So in the circular economy, what you are producing finally ends up in your own business, and thus you get an impact, but also consequences for a much larger part of your activities. So control is becoming a wider concept with others, which is changing responsibilities and which is changing also the impact of your activities. Then food system approaches, that is a little bit more in the core of the presentation. It started in Oxford with Polly Erickson. In 2008, they were developing the first food system concepts, which are here presented. It's maybe a little bit difficult to read, but if you carefully look to it, it is based on drivers, social, ecological drivers, economic drivers, that is impacting the activities in the food system, and that of course is impacting the outcomes. This was taken by people on the SCAR working group, Niels Hallberg and Henk Westhoek, who then also said, but what's taking place at those interfaces between then all players in the food systems? So they were looking to products flows, they were looking to money flows, to services, etc. But overall, it always comes back to the drivers which are impacting activities, which are of course leading to outcomes. And if you then think about food system approaches in a most simple form, you have feedbacks that you each time change your course. So this is in a most simple way a representation of a food system approach. Now, what I said this morning, and that is definitely true for all research in the microbiome, and especially if it is linked to the One Health issues, everything is impacting everything. So what we can easily say, we are lost. We are in the beginning lost. Complex systems are depending on so many different parts that are all functioning on their own, that often those systems are destabilized or chaotic. But take ourselves as a human being. We're extremely complex. I don't know exactly how many genes we have, if we have between 50 and 100,000 genes. If all those genes could be on and off, we have 2 to the 50 or 100,000 opportunities. We should be a chaos. We should not be a human being that's able to function. But there are apparently rules in complex systems or laws in complex systems that are making all those individual blocks synchronized in a way that are different cell types formed in the order, in this case, of the square root of 100,000, and that is forming our body. They are working together. It's the same of the networks of different clusters of microorganisms that Emmanuel showed. There are microorganisms able to form a network to jointly work together, even though this enormous variety of microorganisms exist. How can we depict that in a simple way? For those who like to play games, chess, Monopoly with your children, or what else, you recognize playing fields, pieces, players, rules. Of course, there are outcomes. You can win or lose. Some people don't like to lose, but it is unfortunately often an outcome, and there is the timing. And within that, you can make moves. And in the food systems, you can make the moves from production, processing, transporting, cooking, recycling back to production. But here I put it in the 2 different ways, because in a way it's a closed circle of biomass that we need to use in an intelligent way. This is a way of presenting it. This also helps us if there is an external trigger or an external ambition or an external incentive, a subsidy or what else. It will impact the system maybe at one place, but it destabilizes the full system. So it will, in one way, if you look to COVID, maybe it entered at the human level, but then it impacted also the playing fields. It also impacted the incentives that we had to take. It impacted the resources that we could produce and transport. So in a way, all those kind of systems are impacted by all its building blocks. And that is a key issue in our food systems. We are not going to look at one building block, we are trying to look at all of them. So we are going to pose main research questions are, what is then the impact of an external trigger, a stress, a leverage point, or what else? Will it destabilize the entire system, and how? Emmanuel used the word resilience. If we go back to literature on systems, it was Per Bak who was playing at the beach and he was building sand piles. And if you drop each time a grain, you see avalanches along the sides of those sand piles. And at a certain moment it collapses. But when does it collapse and how does it collapse? That are questions that we like to ask also for our food systems. Are they then also able to adapt? That's, of course, a key function. And for that, are they able to learn and evolve? And finally, are they then also evolve in a direction that is sustainable? That is not for granted. Let's give an example in your domain. Suppose that we have a Green Deal objective in an area which is impacting here. I put it at a regulation level, but it could be defined as a goal. It is impacting, of course, if it is focused on pesticide use reduction or organic farming, it is impacting the healthiness of our soils and our microbial systems. That is impacting, of course, what we can do in production in agroecology. It is impacting, for sure, also nitrogen fixation, if that is possible. That is impacting the resources that we can produce. That is impacting the moves that we can make. That is impacting the production systems that we need to build up if we are going to more biodiverse production systems and not only focus on monocultures. That is changing the way the actors are intervening with each other, maybe in agro-food parks of the future. And that is finally impacting the healthy diets that we need, and also the sustainable diets that we need, hopefully included with new products based on what they bring in knowledge in the microbiome domain. So a final word before I come back to the topics that Hans-Jörg has addressed about sustainability. That is not for granted, but let's take the definition of the Brundtland Committee. If we take it literally, the Brundtland Committee said, whatever we do, we should not compromise our future generations. And as a physicist and mathematician, that means for me that the systems that we need to develop should endlessly balance and not lose track and end up in chaos or order. So they need to balance between something and something. And that is what we may call our sustainability boundaries, which also means and indicate that they all should have a lower and upper limit. We can depict it in this way. This seems to be complicated, but it's not at all complicated. We have a zone where we have chaos, overheated, overexploited planet. We have a zone where everything is frozen, more a desert-like planet. And we have a zone in between, the green zone, which is called a safe, a fair, a just, a sustainable operating space, which is large, which allows us to play, but not in endless manners. Because if we think that we can do and only think about endless growth, growth, and growth, we end up for sure in scenario one, unsustainable outcomes. We can also lose our tracks, ending up in the dead zone. But if we do it correctly, we are able to endlessly balance in the green zone and follow scenario 3. And that is our win scenario. We can do it. Those kinds of balancing patterns are very important in nature, but I don't go back to that. A remark to make, I think if we are talking about sustainable systems, we need to have for all of our indicators upper and lower limits. This may give an extra reflection to the Sustainable Development Goals, which are fantastically defined, but do they all include upper and lower limits? So our sustainable food system partnership is focusing on the post-harvest gate, but as questioned, we cannot forget, of course, what's taking place in other domains. However, in our science domains, we need to focus. We will do that, as Hans-Jörg has said, on 4 thematic areas: change the way we eat, process, connect, and govern. And we do it in 4 horizontal activities in co-funding, in observatories, building knowledge hubs, and science to policy interfaces. So we work in 2 ways, creating generic knowledge on one side, and on the other hand, build on all the wonderful case studies to learn, and test. And of course, the microbiome world and knowledge domain will be very active, at least in the first 2, but in all horizontal activities as well. We can maybe complexify it further, that whatever topic we like to touch upon, if we look to the systems overall, we cannot look to only making a new technology or a new product, or only look to a specific microorganism in its environment. We have to look to the systems overall. And that are topics that are listed here, but can be debated, of course. Eco-villages, where everything is linked from food consumption, production, at the site, new actor involvement, territories around it, etc. Those are topics that are addressed hopefully in the food system partnership of the future. They are then connected, as Hans-Jörg has shown, where I've added fair and just, I think, and adaptability that are key topics with all the other partnership. If we don't address them, we will not end up with our sustainable food systems of the future. And with that, I'd like to thank all my colleagues, young and many, many years young, for their inspiration, and also still I'm working with them and inspired and learn each day. And I thank you very much for your attention. I'm inspired by Escher, by all his wonderful drawings where everything is connected to everything. And I hope you will become that as well in the partnership and contribute to it. Without you, no partnership. Without you, not a sustainable future. Thank you.
Thanks ever so much, Hugo. And particularly also kudos to bringing in the microbiome so elegantly, despite the fact that you admitted at the very beginning that this is where you may be feeling out of depth in certain parts. So I am, as in the earlier session, taking questions as part of the panel. So we're going to bring Hugo back, meaning that we are now moving on to a couple of talks which are really focused on a legislative update on EU laws that may be able to help pave the way for sustainable solutions in food production, soil health, agriculture, and biodiversity through the use of different microorganisms. And the very first person I would like to introduce to you today is Domenico De Serio. He is a senior policy officer in the pesticides and biocides unit of DT Sante with a background in food microbiology. And he will be talking to us about microorganisms used as plant protection products, biopesticides in particular. Domenico, over to you.
Thank you very much, Bettina, and good morning to everyone. I'm gonna just share my screen now for my presentation. I hope you can see it. And yes, indeed, thank you very much, Bettina. Again, good morning, everyone. I'm Domenico De Serio, indeed, policy officer in DG Santé. Bettina has already introduced me. This would make me save some time. And so to go into the topic of the presentation, of course, we are here with our activities also to discuss about the Green Deal and the Farm to Fork. In particular, our regulatory activities on microorganisms using biopesticide have been focusing on two of the objectives of the Farm to Fork strategy. So the reduction by 50% of the overall use of chemical pesticide and the support to the EU organic farming. So in order to chase these goals in particular, we can, of course, act from different angles. And from the plant protection product side, of course, we can support this transition by providing more biological alternatives, so biological plant protection products. Then the questions, why focusing among several biological plant protection products, why we are focusing and giving priority to microorganisms? The answer is quite simple. As you can see in this chart, this is the number of low hazard active substances which have been approved in Europe in the last 12 to 15 years. The dark bar at the bottom, the blue bar at the bottom, represents a microorganism. So it's pretty evident how first of all, the trend of microbial active substances used in biopesticide is increasing, and it's quite obvious, especially if you see the last 2021 data, how microorganisms represent the biggest of these groups. So we have at the moment more than 60 substances approved in Europe, which are microorganisms. And in addition, microorganism can be used also in organic farming. So in order to, let's say, exploit the potential of microorganisms, although also in plant protection, it is important to know more about surrounding microbiomes, as it may also help to discover indeed innovative solutions for plant protection, which are safer for human beings and environment. So opportunities in plant protection by using microorganisms can be created with more specific researchers on interactions, plant soil, for instance, soil environment, plant human health. It is important also to favor good agricultural practices like the IPM, the integrated pest management, which will increase soil health, hence an healthier plant. So reducing also the use of chemical plant protection product, which might also itself disrupt some symbiotic relationship between, of course, the plant and the microbiome. But the question would be, okay, we support the farm to fork strategy by using biological active substances, which are microorganisms, but how we act? In order to explain where did we tackle our action, we need to just have a brief, quick look on how the approval system of plant protection product works in Europe. So first of all, in order to take an active substance to the market, a company, an applicant shall submit a dossier that will be evaluated by rapporteur member state for starting the risk assessment. The risk assessment then is continued at EFSA level. And when the EFSA conclusion is produced, there is basically a risk management decision. So the Commission and the Standing Committee on Plant, Animal, Food and Feed take a decision whether or not approving the substance. At the moment, the main issue of this whole process, since the application of the applicants, is the application and submission of the dossier until the market makes the substance available. I mean, until the substance is available to the market, the main issue is the time. Sometimes it can take longer than what it should be. And hence we decided to, in order to speed access to market of this substance, we decided to work on the regulations, which are basically providing for the data requirements to be provided for taking the active substance to the market. So Regulation 283/2013, and the data requirements concerning the plant protection products. So Regulation 284/2013. In addition, we consider also necessary to amend also the uniform principles, so which is basically which are included in the Regulation 546/2011 and the Annex 2 to Regulation 1107/2009. So in green you see the data requirements, so whatever the applicant shall generate or collect as a data to compile the dossier, and in blue whatever dictates, let's say, provides for the methods under which this data shall be evaluated. So we have produced then at the end 4 implementing acts modifying this regulation. But then in order to amend properly these implementing acts, in order to amend properly this regulation, which should be then the driving principle for making this revision effective. So first of all, in order to improve the current regulatory situation on microorganisms, we needed to embrace the new scientific approach. We know more about microbiomes now. We have more information about also the previous assessments which have been done in the past. And we took this to the new regulation, in these new amendments. An important point is that the new regulations, so these amended regulations, will stop mimicking the chemical approach in the risk assessment, because the current regulation into force is a bit, let's say, mirroring the chemical approach, while the regulations we are taking now on board will improve this situation. And all in all, also, we are reducing the burden for the applicants. We are trying to make these substances quicker, faster to the market, because we are really asking what we need to know. So we are introducing a tier-based approach, basically, which includes mandatory and conditional requirements, which will be required only in certain circumstances, so to reduce the burden for the applicant. All in all, this activity will increase the quality of the dossier, the quality of the risk assessment and the risk management, to take the microorganism quicker to the market. Just to give you some quick insight on the scientific updates we are delivering with these implementing regulations, something which was really much appreciated was on this activity was the fact that the biological properties of the microorganism compared to the text currently into force are really centered in these regulations. So basically, for instance, data requirements which will be required in section 5 can be triggered or dismissed or waived based on certain biological properties of the microorganism. So if the microorganism is a virus, for instance, certain data would not be required. And this is more clear in the current regulation. To make you a practical example, this slide concerns the assessment on pathogenicity to humans of the microorganism. So basically, the applicant shall prove that the microbe used in plant protection product is not pathogenic to humans. And the regulation currently into force is a bit like asking too many data, like even when it's not fully needed, while the new regulation will be organized in a tiered based manner. So here you see the example of 3 tiers, where if, like, let's say, weight of evidence approach based on biological properties or medical data already existing would be enough to conclude on absence of pathogenicity to human, the applicant can stop the assessment here. So we can safely conclude that there's no pathogenicity to human. Also, like, this is good also for ethical reasons, because with this approach, we will reduce the occurrence to animal models. We are now at the moment proceeding quite well on the time schedule. We had recently the 4 implementing regulations endorsed by the member states in the Standing Committee of Plant, Animal, Food and Feed, and we are now translating these documents. By the end of April, we will launch the scrutiny to the European Parliament and the Council, and the final aim is to have the 4 implementing acts into applicability in Q4, should be beginning of November 2022. I just would like to conclude, because I think my time is done, with this last slide. So just a take-home message, which is quite important for us. All in all, to achieve the farm to fork objectives, we know that we need innovative tools, and microorganisms used in plant protection product as well can really be supportive of that. The amendment we are providing with these implementing acts would increase the quality of the dossier, and all in all will foster access to market of biological substances which are based on microorganisms. There was already a public consultation on these implementing acts, and we received several positive comments acknowledging the importance of having put the biology of the microorganism at the center of the assessment, which is important. But at the same time, there was a concern raised by many applicants, which was based on the fact that risk assessors often are lacking expertise, because the plant protection world, let's say, has plenty of chemists, and there's not enough microbiologists. I heard before in the previous panel discussion, there was a mention about the need of having more microbiologists in our world, and I fully agree with that. And this is something we really feel in the plant protection product environment. So it's a matter now of member states to raise political will to build specific internal expertise, hire microbiologists, and prioritize biologicals. I think that was all from my side. Yes. And floor back to you, Bettina. Thank you.
Thanks ever so much, Domenico. In that case, fingers crossed that you manage your timeline as well. You've got it planned, because I'm pretty sure that from an industry perspective, this fastened timeline is going to be of interest as well. So this takes me to our next speaker, Marta Pongelini, who is the deputy head of the Unit on Animal Nutrition, Veterinary Medicines at DG Sante at the European Commission. And she will be talking to us about microorganisms use as feed additive, or in general feed use, with a specific example of feed probiotics. So over to you, Marta.
Thank you for the invitation to this really interesting meeting, because for me is a source of a lot of information. I'm surprised how many things I need to learn still. My presentation, my short presentation, is just on the practical aspect, and it is quite an answer to some of the requests from previous speakers on the need to have a clear rules for the use of microorganisms, because in our case are microorganisms, and in a sector, I can say small sector as it is animal nutrition. I would like just to mention that the use of microorganisms is very, very long has a very, very long history of use in animal nutrition, because there was just an empirical way, I can say, from our farmer use natural fermented milk, for example, or the rumen content to help young animals to start the rumination. So really, the use of microorganisms, it was something we can say traditional around Europe, so from North Europe to the south of Europe. So that is something. And the example is clearly already in 82, this concept was already present, not really in that way, because at the beginning, the use of microorganisms, kill microorganisms, derive from the use from a request from the industry to reuse the fermentation bed derived from beer production, or at time also from antibiotic production, to as a source of protein, because that it was absolutely one of the first examples of circular economy. This use, revised with the knowledge, whatever, is still present, and we have the present regulation, so-called feed marketing regulation, that regulated this kind of product. Now we are speaking about something of kill microorganisms, so not really what we are speaking now. We need to have to arrive to the 93 to recognize the use of alive microorganisms. And someone mentioned the problem with the suspect of pathogenicity, animal disease transmission, that it is one of the reasons that we have. We were afraid. So, but in 93, the one of the key points was the reason of the use of microorganisms to stabilize the flora of the digestive system. That is, in italic, is the recital of this kind of council directive. Council directive, and that it was, I can say, amended with following with another directive to establish the status of feed additive for this kind of product. What it means? From one part, as I mentioned before, the use as feed material without pre-market authorization. But when we want to claim something for your microorganism, and I explain you what I mean later, you need to introduce this product in the system of feed additive. And just for your information, in 2003, we have authorized on the market 23 microorganisms. Why I put this sentence? Later on, I will illustrate you what is the meaning. Because in 2003, we have the present regulation, so the present rules regulating the use of microorganisms in as feed additive. That is the more interesting part of the use of the microorganism. Still, we have the recitals that the meaning is exactly the same, to stabilize the flora on the digestive system, but that it was extremely important because it was considered a source of a resource to as alternative to the use of antibiotics as growth promoter, because that when the Europe first in the world decided to ban the use of antibiotics as growth promoter, one of the conditions was to have available alternative to reach to compensate the lack of this kind of product. At the beginning, in 2003, we are really in the history of prehistory. one of the most criticism for this ban was the lack of competitiveness due to the reduction of the use of antibiotic for competitive of our farmer in comparison with the third countries. And that it was really a demonstration that it was not true, not only for microorganisms authorized as with additive, but I repeat, mainly for the use of the microorganism, that it was not at all true. Now the situation is a little bit better also around the world. No, we are not alone having this kind of ban. But in 2003 was really a strong innovation. Another aspect was the introduction of the use of microorganisms, not just having an effect on the animals, but also as technological effect. And you have mainly as preservative and as silage additive. So that is the framework of the present framework still in force now. And really, if we go ahead in this kind of illustration, the system requires obviously a pre-market authorization specific for animal species or animal categories. Again, some of the previous speakers indicated that the microbiome is completely different from the age for human. You can imagine from the age and from species. Not only in terms of safety, but also in terms of efficacy. So that is something that is extremely important in the sector. And it is the EFSA evaluation, because the evaluation is made by EFSA, is based on two big aspects. So these two big aspects, safety and efficacy. We provided guidelines to the operators. Guidelines are a regulation, and EFSA guidelines you mentioned here. You can have the regulation 429/2008, and the EFSA guidelines regularly updated following the scientific development. What is also important is the authorization done at the European level are available, immediately available in all member states. It means we don't have an evaluation in each member state. We don't have a commercial or a marketing authorization after the European Commission authorization. That is important because all farmers can have available, and that is depend obviously from the market, the same product. Here you have very short and simple way how it's work our system. In any case, we need to receive an application from an applicant. So that is sometimes surprising because it's true, if the applicant are not incentivized to present a dossier, to submit a dossier, it's very difficult to find out product on the market. And that is not really a statement, but is the reality. So we need to create a good environment, also legal framework for an applicant to incentivize the submission of the dossier. That is absolutely important. The Commission, in any case, is the actor because EFSA is the technical body, and the Commission with the member state, because really, as usual, the member state, the scoper for the member state, decide to authorize the product for the European market. And that is very simple. This product, just to give you an overview, are listed in the register public available of European feed additive. I can add this kind of thing. So you can find whatever is on the European market, and only the product listed in that register are authorized. I repeat it because in Europe we have different microorganisms used, but really the only legally available are listed in that register, but that is just for information.
Marta,
Yes?
I am very aware of time. Can you please start bringing it towards the end? And I was wondering whether you could focus specifically on kind of what's in the future in terms of sustainable food, also considering the farm to
Yes. Okay. That is, I suppose, what you are asking, because that is the efficacy aspect. The efficacy aspect are what is the present situation. Just answering what the Mr. from the European Parliament, sorry, I don't remember the name, asked, a good compromise by the production, intensive farming, and the future. So we have the production, the zootechnical additive, and the other zootechnical additive, and that is the future development. For example, reduction of contamination of salmonella. So the use of this kind of product for the future. The use of this kind of product to reduce to improve the growth of the animals, reducing, for example, the malformation of the spine. That is one of the most important thing that they are exploring, or improve for pets the gut flora condition. In the future, also the future is also the effect on feed, because you can see you have 93 already authorized, but this is an expanded sector for the technological use to reduce the feed waste for us, and to increase the use of marginal feed, so the exploitation of the marginal feed, and also as preservative, and the preservatives are quite still difficult. Okay, this is the list that is not interesting for you, but this is the list of what is the future. We are, you can see there are a lot of things already done in the sector, and we are revising the 8031. This is, we need to make a proposal by the end of this year, or early as possible, where we focus on the use of the microorganisms in what is not really even possible, not really still developed now. So the fact to having an effect on animal welfare. Now, one of the limitations of the regulation is to have more focus on the production instead of other functionality of the microorganism, and we would like to really to explore the animal welfare, reduction stress, reduction of or more resistant to the climate condition for livestock animals, also for pets, because we have also some microorganisms authorized for pets. The fact that the increase of the use of these microorganisms can contribute to the use of the reduction of the use of antibiotics, so an improvement of the gut flora in general. You need to consider that we are speaking about feed. We are not speaking about therapeutical use. That is one of the problems that we have. So in the past we needed to refuse some of the application because the claim was on therapeutical use. We are speaking about feed. Therapeutical use is something different. we act in animals in a good condition, and we improve the good condition, stimulating the proper gut flora. And after, but not the last, we want to develop environmental effect. Consider that environmental effects are already foreseen in our regulation, but really difficult to demonstrate, because that is one of the key points that we have, because still linked to the zootechnical effects, so productivity, and secondary is the zootechnical, the environmental effect. We have already a product, for example, authorized with reduction of livestock emission, and we want to, I repeat, a better exploitation of resources, and that is something that for the moment is not still well implemented in the present regulation. By the revision, we want to implement this aspect via different legal tools, so not just on effect as they need to be evaluated by EFSA, but introducing the system of claim that is well known in Europe, where you can demonstrate, I can say in an easier way, what is the associated effect to your product. So we have already example that the use of some enzyme can reduce the phosphorus pollution or nitrogen emission if for use of some amino acid or the use of amino acid. What is the limitation? Is the limitation of this kind of use is very good, but the farmer need to be recompensated for this use. And that is at present one of the limitations of this new product. Because if they are not compensated, there are no incentive to use this kind of product, because it's not recognized the investment done to meet the new requirement. So that can be done by really economic way, but also by legislation, by different ways. So it's, honestly speaking, is out of our Insante aspect. But that is really one of the problems that we receive when we start to incentivize the submission of this kind of product. As I mentioned before, we need to create a legal framework favorable to have this kind of submission.
Well, Marta, hopefully with lots of dialogue between different stakeholders, we can actually create that kind of place where we can provide different incentives. And I was actually just about to say, I think I have to move us on, but I can see you've got your thank you slide up already. So thank you from my side as well from your perspectives. We're going to come back in the panel again. But for now, I want us to move on to a range of oral slam style talks. So short, quick talks that introduce us to what microbiome applications actually are, what are they in practice, and what is research doing at the moment to make this happen. So for this, for our first speaker, I'm going to introduce you to Magdalena Gacinska from the European Commission's DG Research. She's working on food systems and working on further developing the Food 2030 initiative. Is also contributing to the mission on soil health and food, explores, launches and deploys various RNA-based solutions to the European Green Deal, one of them being our very own project, MicrobiomeSupport. So I'm going to ask my colleague Rike to share the slides for you. So this is coming, and going to hand over to you, Magdalena. Thank you.
Thank you so much, Bettina, for the introduction. Good afternoon. We are 12:01, so I think good afternoon right now. Good afternoon, ladies and gentlemen. I will very shortly talk about how RNI can facilitate the uptake of microbiome tools and products, and introduce you to 4 microbiome projects that Bettina has mentioned under the coordination of the MicrobiomeSupport funded under Horizon 2020 program. But before that, I would like to thank the organizers for the opportunity of speaking on this event, as the exchange between scientists, industry, and policymakers is more important than ever to provide a wide vision of the microbiome future from different angles. Next slide, please. Firstly, let me explain you the Food 2030 that was already highlighted by Hans-Jörg at the beginning. Food 2030 is a concept referred to in the Farm to Fork strategy, and it is a policy framework to future-proof our nutrition and food systems for research and innovation. It precedes the Farm to Fork strategy, as it has started in 2016, and fed the research dimension to help develop the Farm to Fork strategy. We have identified a number of priorities that Food 2030 is keen to tackle. The first one of this is nutrition for sustainable and healthy diets. That's everything that relates to keeping people healthy. Food safety is also embedded in there. And the second relates to transforming food systems so they become climate smart and environmentally sustainable throughout the whole system. By climate smart, we mean not just in terms of climate mitigation, but also in terms of climate adaptation. The third priority relates to circularity and resource efficiency for the whole food system. And the fourth is about innovation to empower communities. And by communities, we mean cities, towns, and rural areas. To achieve the Food 2030 priorities, we need to apply system thinking through 4 drivers. The first is through research breakthroughs and bringing transformation capacity of information and communication technologies, and also social sciences and humanities, especially with respect to consumer behavior and how we can nudge consumer behavior towards more healthy and sustainable choices. The second is about innovation and investment. All sorts of innovations are happening on the ground, and our role is to help these innovations to scale up and scale out. Thirdly, the open science. Thirdly, the open science, open data, and fostering a multi-actor and public engagement approach. And lastly, the international collaboration. Next slide, please. Talking about Food 2030, we need to mention as well the 10 pathways for actions described in the document I have shared in the chat already, and Hans-Jörg was mentioning very briefly as well. The pathways will guide you through the current and future core development that you can see represented on this tree in dark green color. And part of it is microbiome. The outer layer lists the relevant part of Horizon Europe. The inner layer, the Food 2030 priorities that we have just discussed in the previous slide. The entire tree is driven by EU policies as nutrients. And the sun, the European Green Deal, is allowing the photosynthesis. The pathways for action represent key, key levers of change where RNI can have a deep and multiple impact in realizing the food system vision. Each pathway sets the systemic challenges, the expected co-benefits, barriers, and enablers of change, and highlights potential research innovation. Next slide, please. Microbiome world, the pathway. Sorry, is it me, my background voice, or somebody is speaking over me? Okay, maybe it's something from my computer.
It's fine from my side, but I'm going to go through and mute anyone who is not muted at the moment, Magdalena.
Thank you. Okay, so microbiome world, the pathway important for our discussion today, describes challenges, co-benefits, barriers, and enablers, as I have stated before, and points out the research and innovation needs, dividing them into 2 subgroups, technical and non-technical interventions. I highly encourage you to consult the free page that I have shared in the link in the chat as well already before. But let us go back in past a little bit right now. There was a recognition of much untapped potential of the microbiome across the whole food system and its relevance in context of the Food 2030 initiative. Moreover, the wide acknowledgement of overlapping funding, unaligned research methods preventing meaningful conclusions across experiments, and innovation system not ready for complexity of microbiome studies. These aspects has given an idea of funding a group of projects to start aligning the research and funding field for more impact and exploring the potential. Next slide, please. And therefore, with all of this background, all of this history, the under Horizon 2020 calls, we have funded amazing microbiome project dedicated to food systems. So specifically talking, the Microbiome Support project with the coordination and support role of microbiome at the EU and IPLF level, and with the budget of 3.5 million, as well as the 4 innovation actions, each with a budget of 10 million euros, circles working on impact on food system microbiomes on food safety, productivity, quality, and environmental sustainability, holofood, hologenomics for sustainable production, master, microbiome applications for sustainable food systems through technologies and enterprise, SIMBA, sustainable innovation of microbiome applications in the food system. And with this brief explanation, let me give the floor back to Bettina to introduce the 4 representatives of the mentioned projects that are with us today to give more insights of the recent developments of their projects. Thank you so much.
Thanks ever so much, Magdalena. And I'm actually very excited now to introduce those people who are currently working on microbiome applications that really could make a difference for the European Green Deal. The first being Professor Marco Candela from the University of Bologna in Italy. Marco is an associate professor in the Department of Pharmacy and Biotechnology in the Unit of Microbiome Science and Biotechnology, and he is the coordinator of Circles. Marco, over to you. Your pitch of what Circles microbiome applications will do for the European Green Deal.
Thank you very much, Bettina, and good morning, everybody. I'm really happy to be here for sharing with you some advances from the Circle project. So next slide, please, Bettina. Or can I move by myself? No, okay. So here is the Circle project. Essentially, we are 30 partners, of which 15 academic institutions, and 12 companies that we work together in the same environment for providing concrete application for improving the European food system. Next slide, please. So our aim is to discover, translate, and communicate innovative microbiome-based application to improve the European food system that in terms of quality, productivity, safety, and sustainability are integrated in the same microbiome-based solution. Please, next one. So essentially, we target 7 different European food systems, from spinach, tomatoes, poultry, pigs, and different kind of aquacultures all across Europe. And we want to provide a new paradigm of food production that conceive microbiome as a potential tool for improving our food system in general, but also the products that derive from the food system. Please, next one. So essentially, we defined the smart microbiome food system as a food system where microbiome circulation and dynamics across all the actors of the food system are optimized for better performance in terms of productivity, quality of the product, and sustainability and safety. And we aim to achieve the level of a smart microbiome food system by implementing circular microbiome biotechnology application tailored to the different microbes in food system for improving their performance and helping to improve the food system at all. Next one, please. So generally, in the project, we start from the production of more knowledge, since, as we were saying before, in many presentations, we need more knowledge on microbiomes. We need to understand better how they work and how they provide probiotic functionality then can be exploited. So we will look at microbiome, we'll learn from nature, we'll understand how they work, and then we'll model the optimal microbiome configuration that is needed for improving the food system performance. And then we will try to act, pushing the microbiome towards the optimal configuration for improving the food system performance. Next one, please. So here are some advance from the project, very fast. So for doing that, the original approach we apply in Circle is the network modeling approach. So where we will implement a principle of microbial ecology for the design of the intervention strategies for improving the microbiome in food system. So everything is based on microbial ecology. So how microbiomes behave and how the different microorganisms in microbes interact. Next, please. So essentially, we are now in the process of defining the probiotic microbiome hubs. So the group of microorganisms acting in the different microbial ecosystem which are involved in food production that provide specific probiotic properties. So we are searching these probiotic hubs as probiotic actors, which are important for providing concrete functionalities which can be translated in a better food system. Next one, please. So essentially, we have defined some keystone species in this probiotic hub that we know that must be promoted by our action, but also we define some species in kind of this biotic hub that are the microorganisms that we know that we need to be combated by our action. So this ecological information inform the best action to be provided for improving the food system microbiome in terms of microbial ecology at all. Next, please. So here there are the results from 2 of the 7 circle food system. This is the poultry food system in which we explore the whole production chain, producing 2,000 different samples. Next one, please. And so we provide a lot of microbiome data from these samples in terms of compositional structures. And also, next, please. And also models. So how the different microorganisms in the different micro ecosystem in the food production interact each other. Next one, please. The same approach was performed for the fig food production chain and also for aquacultures, from which we got thousands of samples, and again, analyzing the samples, producing microbiome data. Next one, please. And the modeling for understanding the ecology of microorganisms in food production system. Next one. And finally, the final one, please. Okay, and finally, we provide a lot of knowledge for instructing our intervention action. So what we know now, we know that the food chain's microbiomes dynamics and their network provide an important ecological dimension to understanding the role of microbiome in food production. And this knowledge needs to be exploited and will be exploited for the identification of the probiotic and the dysbiotic hub that need to be boosted or contrasted by our actions. So we are now designing some tailored intervention strategies for the promotion and the enhancement of the probiotic role of the microbiome in food production that are directed to the improvement of the probiotic hub through the action on the keystone species in the probiotic hub and to the contrasting of this biotic hub and also providing action that counteract these biotic species. And this knowledge will be put on action in our intervention strategy, and then we are going to implement on the real world food production chain our intervention strategy just to see if they work and if they will be able to improve the food system performance at all. Thank you very much.
Thanks very much, Marco, for this whistle-stop tour of circles. So our next candidate is Professor Paul Cotter from Teagasc in Ireland. He's the head of food biosciences department at the Teagasc Food Research Center, and he is the coordinator of MASTER.
Good morning, and thanks ever so much, Bettina, and thanks to everybody who's in attendance today. It's a great pleasure to tell you about MASTER and the fantastic team that we've gathered together to carry out this research. It spans 30 different organizations right across the EU, and we're making tremendous progress towards developing these microbiome applications that will suit sustainable food systems by improving different technologies and through enterprise. Next slide, please. So MASTER spans multiple different food chains, including the marine, plant and soil, animals with a particular focus on methane mitigation, but also feed conversion efficiency, waste streams and fermentation, whereby we can take materials of low value, including raw milk substrates or basic milk substrates, peels and pomace from the cider industry, and add value to them by fermenting them with the right microorganisms. Looking to see what microorganisms are present in both the food production and food processing environments to see to what extent they impact on the microbiome and safety and quality of foods, and ultimately on human health. So to do this, we have a number of different products and process areas, and these include very many of the different applications that you've already heard about today, such as particular strains for biofertilizing or biocontrol of pathogenic microorganisms, probiotics, and so on and so forth. But ultimately, these different product and process areas span 5 different categories. So we have strains or consortia, so groupings of individual microorganisms. We have different services and processes. We've developed new foods and feeds for animals, new molecular analyses to allow a very accurate and rapid determination of what's present in a particular microbial niche, and the databases that facilitate that as well. And indeed, it's this latter topic that I've selected to focus on to provide you with an example of the sort of outcomes or outputs that we've generated through MASTER. So next slide, please. So ultimately, while we've heard a lot about modulating the microbiome and changing it for the better, one of the key requirements is to first to understand what microbes are present in a particular microbial niche, both what microbes and what microbiomes, all of the different components of individual cells that are present in that population. And this is of key importance right across the food chain, not only within the food production environments where you can look to see what's present in the soil and what microbes might be there that are contributing to plant health, and those which might be contributing to disease and how you can modulate those. But you also need to very rapidly determine what microorganisms are present in food processing and present on the surfaces of the walls present in the plant, on the hands of the food processor themselves, present in drains, and where different undesirable microorganisms might be entering into the food chain. It's equally important to know what microorganisms are present in fermented foods, in that the microorganisms present are responsible for contributing to the safety of those foods, but also to their flavor. And something that people are increasingly appreciative of is the microorganisms in those foods that can contribute to health in a broad variety of different ways. Now, the conventional approaches that we and other microbiologists have used for decades relied on agar and Petri dishes. There have been some improvements from a molecular approach whereby we use qPCR and other strategies. But the challenge with very many of these approaches is that they can be slow and inaccurate. In other instances, you might only be possible to detect one or a small number of different target microorganisms at a time. And quite often you can only find what you're looking for. So if you are concerned about finding salmonella in your food, you might do a salmonella screen. It may be negative, but it won't necessarily tell you if Listeria or E. coli are present. So hence we have particularly focused on looking at microbiome-based approaches to studying individual food samples and the samples from right across the food chain. And this involves a combination of rapid, high throughput, portable DNA sequencing devices that have in essence democratized DNA sequencing. So you no longer need to send your sample to an industrial facility or an academic lab that has spent 100,000 or numerous hundreds of thousands on DNA sequencers, but you can bring a handheld device into the field or the processing facility, and through cloud computing, send your data to databases to allow you to very quickly and rapidly determine what microorganisms are present. So using these approaches, it's possible to study all microbes in parallel, the entire microbiome, not just those which you're looking for. As I mentioned now, there are portable sequencers that are available. And while we've been enhancing and improving all of these methods and technologies to facilitate the availability of these approaches to everybody across the food chain, right across Europe and indeed globally, one particular Achilles heel that we've recognized is the absence of suitable databases to allow you to ensure that the DNA sequencing that you're carried out very rapidly and accurately determines which microorganisms are present, which is obviously of key importance. And we've addressed that by accumulating data from right across the globe and locating it in dedicated databases that in the coming months will go live and be publicly available for anybody who would like to use them. In the first instance, focusing on the microbiomes of the foods themselves, and then expanding to include all of the samples that we've accumulated relating to environmental samples. And in addition to doing that, we've not only taken existing data, but we've carried out sampling of hundreds of different food sample environments, food processing environments right across Europe, thousands of samples, hundreds of different locations, and have added that to the database to allow a very accurate assignment of DNA sequence data going forward. In the interest of time, I'm going to leave it with just that example, and we'll be happy to chat about this again later, but thanks, Bettina.
Thanks very much, Paul. So you do have a question in the chat, which I will ask you to respond in written, please, because I can already foresee us cutting the questions and answers at the very end of our session. And likely I will ask for all of your patience for a little bit longer, so that I can at least give all of the speakers and the main panelists an opportunity to speak as well. Our next speaker is going to be Professor Morten Limborg from the University of Copenhagen in Denmark. He is the coordinator of Hollow Food and a molecular and evolutionary biologist. Morten, over to you.
Thank you very much, Bettina, and thanks again to you and the whole UFIC team for setting this up and inviting us along to share our work with this interesting network. But yeah, first, so Hollow Food, in our project, we have zoomed in and only really focused on two systems, which is poultry and salmon aquaculture. But then we're trying to apply this deep evolutionary approach. But before we're getting there, just if you jump to the next slide, Rita, that's just a quick overview of who we are. We're cozy. Oh, it's already, sorry. Dense consortium, you can see here, we're 11 partners from across Europe with some researchers, but also some very impactful industry companies in the food production sectors. So this is providing a lot of useful synergies and interactions. But before I then go on, I would just take you on a very, very short time travel, if you go to the next slide, and then just come up with a very concrete example later on to convey a general point. But basically, if we just look at some numbers, so if we go back to the discovery of the earliest life ever detected, it's like 3.7 billion years ago. And if you then fast forward to the first occurrence of any multicellular life, so basically any two cells coming together to differentiate functions, we're looking at the milestone of 0.5 billion years ago, which means that everything that came after, including us and our animals and plants, we really have evolved in a microbial world that have been shaped and governed by microbes. So trying to understand how we humans, our animals and plants function, including in production systems, without taking the microbiome into account, just makes very little sense to us. So if you go to the next slide. So yes, as we've heard today, numerous interesting examples, we all know that that we have these very well-known functions of the microbiome that we're looking into, for instance, as probiotics, as exemplified here with the porcine probiotic product. And we also know they have very crucial immune functions, helping us combat external pathogens, as illustrated in the upper right corner. But really, once we really start to dive into these data and look at what's going on in there, it's still a huge black box with a lot of unknowns that these microbes are able to do. So if we allow ourselves, with just a little bit of extra time and maybe funding, to not just pursue the obvious that we set out to in these consortia, but also allow some time to pursue some of the unknowns that kind of emerge along the way. And here I will give you a very concrete example. If you go to the next slide. So while we have a lot of focus on the digestive role of microbes in animal feeds and so on, what has been less focused upon is, for instance, to get rid of toxic metabolites. So here's the case of our salmon farm. But I think this pretty much goes for most farmed animals, that they are very, very often fed ad libitum, or at least they eat at a much higher rate than their wild cousins, right? And if we take the instance of salmon, what happens here is then that you get much, much larger concentrations of ammonia accumulated in the gut compared to the wild counterparts, right? And what this means is that this might actually reach concentrations where it becomes toxic to the animal, here the salmon. So what we actually discovered is that there's one specific bacteria of a mycoplasma species that is associated with salmon in different farms and different situations, and they seem to be correlated with their health and performance. But what we could show there is that this microbe in particular has a complete pathway for getting, it's called a arginine pathway, but basically it's a pathway that can help you decompose ammonia in these, right? So I call this like the trash man effect. So basically, beyond just digesting feed and combating pathogens, they might also have other functions, for instance, as this one, where they might help detoxify secondary metabolites. So yeah, if you go to the next slide, I'll just kind of wrap this up by conveying this message that, especially to the funders out there, but also people working with this data, to just give yourself and us a little bit more time and money to pursue some of these unknowns that we're not expecting when we write these proposals. Because I really think there are a lot of unknowns there that we are not just aware of. We don't have the information at this point to predict them. But if we allow ourselves to keep our eyes open along the way, I think there's a lot more to be gained than just the obvious. So basically this GIF is just conveying this hologenomics approach, where if you want to understand phenotypes of terrestrial or of fish or farmed animals, you need to look at the holobiont, so the host and the microbe, as a single unit when you analyze the data. So with that, I'll wrap it up. There's one more slide, but basically just for information, if you want to look more at what we do in Holo Food and in the aquaculture group here in Copenhagen. Thank you.
Thanks very much, Morten. And that brings me on to our last speaker on specific microbiome applications, which is Professor Anne Pilakto from the Natural Resources Institute in Finland, who is coordinating SIMBA. Over to you, Anne. So you're still muted.
Yes, thank you, Bettina, and for the whole EUFIC team to organize this nice meeting. And it's my pleasure to present some of the SIMBA achievements. The next slide, please. So our aim is to get a better understanding of microbiome structure and functions that are related to marine terrestrial food chains, and also to verify the sustainability of microbiome innovations. And this will result to increase food production, quality, safety, nutrition, security of the food. And we have now 21 partners from 11 countries, and we have these 7 different technical work packages. And I will now go through what kind of achievements we have got during our project. So next slide, please. So I have collected from our last periodic report what we have achieved. So we have first collected the data from different sources to produce a database that is now available for the SIMBA partners. So we have collected information from marine soil, food, microalgae, and cyanobacteria that can be used for food and feed. And they have been from literature, but also from our own sources. So then we have done a lot of work with the microbes to produce these plants. And there we have set up some microbial consortia to produce tomato, wheat, maize, and potato. And for marine microbes, we have demonstrated the growth characteristic of Ulva unhois and microalgae that include yellow, green, and red algae and cyanobacteria in marine and also in fresh environments. Then we have developed and tested fermented products in salmon and sea bass, and the products are based on rapeseed, seaweed, and microalgae. And then we have also described the coastal microbial mat and salt marsh microbiomes that can be used to promote the saline agriculture, especially for tomato and potato. Then for food, we have developed some protocols to treat different tomato, potato, and maize residues for feed ingredients in laboratory pilot scales. And we have found that some of the microbes have very good that they can lower the glucoalkaloids, especially in the potato residues. And then we have also produced some products, food products, for example, for pulses fermentation that enhance the nutrition and healthy quality of the product and also the taste of the raw materials. And the results from sustainable food and human gut are based on the earlier studies. And here we have now shown that the sustainable diet induced changes in composition of fecal polyphenols, metabolites, and bile acids, and also which is very important, it reduces the genotoxicity of stool samples. And for the sustainability assessment of potential uptake of the new products and technologies, we have done some videos for farmers and also for the consumers, so that it is easier for them to change the farming management, and also what the consumers are willing to buy of these products, and if they want to have what kind of price they are willing to pay from these new products. And the next one then. We have collected totally 11 of these key exploitable results. And now, because of the crisis what we have now, I selected these plant growth promoting microbes, and also this that can be used for food production. So we know now that they're not the single microbiomes are not very effective, so that there is needs to have this different of these microbiomes should be there. And then we have these three novel synthetic assemblies that are composed from the bacteria, yeast, and fungi, and they have been tested in the maize, wheat, potato, and tomato. And then we also set some bioactive compounds that are from food process side streams, and tested these all with single microbiomes to develop the effective combinations based on the both microbial and non-microbial biostimulants. And the finding indicate that these bioactive compounds can enhance the growth of beneficial microorganisms, so that this suggests that the signals produced by these PGBMs can act synergistically with the organic compounds to enhance the plant growth and productivity. So these are now in the field experiments, these activities. So I think that this is not okay. Thank you.
Thanks ever so much, Anne, and all of the speakers for this session. I would suggest, in the interest of time, that we are not taking the full time for a full-blown panel discussion, but we do still have some really exciting people that we have invited for this part, which I would love to give the floor for a moment before we, at the very latest, close at 12:45. So these are MEP Sarah Wiener, MEP Josas Olekas, who's going to come back, and Virginie Marieux. And I would like to give the floor first to Sarah Wiener, who is a member of the Committee on Agriculture and Rural Development, a substitute member in the Committee of Environment, Public Health and Food Safety, and the Committee on the Internal Market and Consumer Protection. What are your key aspects that you would like us to keep in mind in context of the discussion of today?
Yes, thank you, and hello to everyone. I'm very pleased to having me here for this very relevant and interesting debate on microbiomes and also on the Green Deal. For me, this topic is key because microbiomes are the foundation of life on Earth. They are complex ecosystems with equally complex internal and external interactions. This complexity makes them difficult to study. For example, it is only in recent decades that science has come to understand the fundamental importance of the gut microbiome for our overall health and the functioning of our immune system. In general, we need more research to understand what causes damage to microbiomes, for example, chemicals like antibiotics, pesticides, or mineral fertilizer, and how we can preserve natural high diversity of microbiomes. We need this to respect their natural complexity, which is the very basis of their natural functions and of the beneficial effects for the environment and us humans. That's why I think it is extremely important for research to explore more about these still poorly understood links between the microbes in our gut and how they influence not just our body, but also our mind and mood, as we know today. In this area, research could usefully inform work on food policies such as front-of-pack nutrition labeling, what is one of my top themes. Current systems for labeling, such as Nutri-Score, do not yet take into account the degree of processing a food product has undergone. I think this is important to understand that we have there to look at the microbiome in our nutrition. But we know that in particular, ultra-processed foods, which have become so common in our Western diets, have a detrimental effect on the gut microbiome. This link between ultra-processed foods and the microbiome seems to be key for combating chronic diseases like diabetes type 2 and obesity. Yes, yet I would claim that this aspect has not become mainstream knowledge. I'm sure that this is an area in which further targeted research could equip us with useful tools to implement the food policy objectives in the Green Deal. However, we also must not forget that microbes are the very foundation of our food production and thus of our very survival. I think science and research could do more to support policy work on implementing sustainable and specifically nature-based solutions to these issues, rather than looking in pseudo-techno fix that will not solve the underlying problems of overexploitation of natural resources, environmental destruction, biodiversity loss, and climate change. Particularly in the context of the war in Ukraine, we must finally end our dependence on high input agriculture systems. Organic farming shows us that is possible. This is the only way of getting out of this crisis in a sustainable way, not further intensification of agriculture based on business as usual approaches that that have got us into the situation in the first place. And I have to mention in the end that putting that jar in the soil to do something for the microbiome, for the soil, is really the wrong way, but this is another discussion. Thank you.
We'll bring you back for that discussion, Sarah. Thank you. So I'm going to go ladies first and pass you all on to Virginie Marieux, who is a policy analyst in the Strategic Foresight and Capabilities Unit of the European Parliament, a neuroscientist by training, and has a passion for understanding how life science and technology can and will impact society. Virginia, what can you bring in?
Thank you so much for this introduction. I'm very happy to be here. Thank you for inviting me. In the interest of time, I'll be very brief. I'm just going to speak a little bit about scientific foresight and how we use it in the European Parliament to produce evidence-based policy advice for members, like my co-panelists. And I'll also anticipate probably the burning question in everyone's mind, which is how can researchers use foresight to make sure that their research is policy-oriented and it reaches the right people. So on scientific foresight, it's a methodology, and I must thank Hugo for opening this session with some very concrete examples. We might have different terms for it, but it's essentially the same idea. It's a way of thinking that we use to study and plan for the future. And what that means is that we study upcoming developments in science and technology, and we produce impartial evidence-based advice for policymakers. The key here, and I cannot stress this enough, is that we cannot predict the future. And that is not what we're trying to do. So what we are trying to do is scan the horizon for developments that may have an impact on society. As we've heard plenty about today, microbiome seems to be one of those developments which we should definitely pay attention to. And that's why I'm personally so interested in it. And we study what the impacts of this technology or development might be. So we use a variety of tools to do that, ways to gain a holistic view of the policy issue. And this is very important because policy issues are almost never vertical. They invariably have cross-sectoral impacts. Again, as Hugo mentioned, you can have a trigger that will impact on many different systems. This is exactly what we're looking at. So for example, we use scenarios as a tool to explore issues that could possibly arise. So these could be extreme, they could be positive, negative, but they have to be grounded in reality. And we use these scenarios to develop strategies and to produce advice on what policymakers could or maybe should do to prepare for possible futures that might arise from the implementation of something like, for example, microbiome-based products or therapies. Not only that, it's also important that we don't rely on scientific advice alone. Of course, policymaking should absolutely be evidence-based, but we must also consider the societal context in which the resulting policies will exist. So again, this has been mentioned before, but here a big issue of public trust. How people are going to react to a particular product is extremely important, as we've seen. And I will say here, as a personal comment, I think microbiomes are relatively uncontroversial compared to some of the things that we do deal with, so you have a big advantage there. But nevertheless, there are still issues that need to be addressed. So that's something to bear in mind. And again here, so I'll just jump straight into how researchers can also use foresight. So it is a methodology again, and it can be very helpful. And I'll specifically address here young scientists in the audience, as I was myself not so long ago. First off, I have to stress the importance of using clear language in all of your work, in your presentations, etc. The speakers we've had today have clearly been experts at this. They're really well practiced, but it is a skill that takes time to develop, and it's very important for us to do our jobs properly. And then secondly, an aspect that was mentioned by Yolanda in the first session is also having regulatory training for young scientists, I think is very important. This is something that I think I was lacking and maybe inspired my desire to come work for the Parliament, was to understand how your research fits into a regulatory context. So this is where foresight really help. So in particular ways of implementing it might be, for example, getting inputs from colleagues in broadly different fields from the one that you're working in now. This can help to anticipate impacts that your particular research area might have that you might not have anticipated. So it can help you to think broadly, perhaps optimistically and maybe realistically as well, about what your research might actually lead to. And I think that's another key thing that was mentioned this morning by Angela, having realistic expectations for your research and the applications thereof. This ultimately should help to make your research applicable, responsible, and to foster public trust and to make our job easier in consolidating all of the evidence to produce for policymakers. So if you're interested, for more information, you're welcome to get in touch, but also I'll share in the chat a publication which has a lot more information on foresight, published by my colleague Lieve van Woensel last year for STOA, called Guidelines for Foresight-Based Policy Analysis. I'll share that now. Thank you very much.
Thanks very much, Virginia, sorry. Yours, without any disrespect to you at all, would it be okay if I skipped you, seeing that we've had the opportunity to hear from you already, because I'm very aware of time. And what I'd like to do is hand the floor over to Elsa Katainen so that she can formally close this session with you. Would that be okay, please? Thank you very much for your understanding. Elsie, in that case, over to you.
Okay. Thank you, Bettina. And dear all, we are coming to the end of the webinar. We have had many interesting presentations and debates on the topic. We have seen that there is a need to bring policymakers and scientists next to the same table. I hope that this event will enhance building bridges. With the food partnership approach of the EU Commission between science, policy and lawmaking, we may support strong future alliances for Europe to make informed decisions and to bring research results faster to the markets. I, as a policymaker, have always been curious to learn about the latest research results, applications and new products for agriculture and the environment. In coming weeks, months and years, we will receive many new legislative initiatives under Farm to Fork strategy, for example, revision on sustainable pesticides use, proposal on bioplastic and feed additives, just name a few. I see that microbiomes may solve major challenges while preserving farming at our ecosystem. I hope you scientists have also received a lot from today's event. I trust that I can speak on behalf of all MEPs that in the future we are more than happy to be in touch with you and hear for new innovations from you and other findings. Thank you all for your participation and have a nice rest of the day. Thank you.
Thanks ever so much, Elsie. Thanks ever so much to all of the excellent introductions to the topics that we've been speaking to, for the incredibly valuable perspectives from the different panelists, from the audience for your super interesting questions and engagement. Apologies for the abysmally bad timekeeping from my side today. I am not proud of that with my German teams. What I do hope, though, is that it's still valuable, and I hope that we can keep that policy and science exchange going from here on. Thanks very much on behalf of MicrobiomeSupport, and good luck to all of us from here on. Bye-bye. Thanks, everyone, for joining. Bye-bye. I can see lots of waving hands. Thank you. Bye-bye.
Bye-bye.
Bye-bye, everyone.
Bye-bye.
Bye-bye.
Thank you, Bettina.
Thank you as well, Yusas, and apologies for the delay in the end. I'll see you shortly, anyway.